Fair use.
Many Bible readers feel puzzled when reading the genealogies in Genesis. They describe patriarchs living for hundreds and hundreds of years. Adam lived to be 930, his son Seth 912, Methuselah 969, Noah 950. What's going on here? Did ancient Bible writers just imagine these incredibly long lifespans? This would seem to be the case, since people today only live into their 70s or 80s, often with the help of modern medicine. These long lifespans must be mythical, right? Well, maybe not. Certain compelling reasons to believe that the biblical authors were recording the actual long lifespans of these patriarchs have persuaded trained geneticists to take these Genesis numbers at face value. The remarkable picture from these lifespans only emerges when plotting them on a graph. After all, a picture is worth 1,000 words. Only then do we see that the average lifespan of these patriarchs who lived before the flood lived an average of 912 years. After the flood, their lifespans began systematically declining, following what's known by biologists as a biological decay curve. A mythical list of ages would be unlikely to take such a predictable, exponentially declining curve. We see that Noah, who was the 10th from Adam, lived through the flood and died at age 950. Noah's son Shem lived 600 years. His grandson 438 years. 5 generations past Noah, lifespans declined to the 200s. Abraham, who was 10 generations after Noah, lived to be 175. We also have Jacob, when he was 130 years old, stating to Pharaoh that he had not lived as long as his ancestors. Jacob later died at 147. 7 generations later, living to be only 120. What's going on with these lifespans? They systematically decline along a familiar-looking pattern that statisticians call an exponential power curve. Plotting their ages does not reveal a straight-line slope, but a curved one. They don't suddenly bottom out right after the flood, nor do they decline eventually. Rather, the lifespans decline along a non-linear, exponential curve over time, and this curve literally passes every test for statistical significance. Whatever is going on here is not some chance occurrence. Their pattern breaks every possibility of being some fluke. Geneticist Dr. John Sanford of Cornell University, who was part of a team that invented the gene gun, noted that these lifespans fit so tightly along this power curve that 95% of the lifespan variance is explained by the number of generations from Noah. This statistical model matches the biblical data so closely that its likelihood of occurring by chance lies below 1 in 1,000. Now that's uncanny. This exceptionally strong correlation allows us to predict how long people would live based on how many generations they are from Noah. For example, the curve predicts that someone living 10 generations after Noah would have a 90% likelihood of living between 137 and 234 years. Similarly, it predicts with 90% certainty that a descendant alive 15 generations after Noah would live between 100 and 172 years. This model is so powerful that the average lifespans predicted by the model are within 10% of the actual lifespans recorded in the Bible. This close match reaches well beyond coincidence. This leads to an even more stunning realization. The lifespans in the biblical text span over 2,500 years of recorded history, and the original portions of Scripture that include these lifespans, Genesis 5 and 11, were produced by eyewitnesses whose lives overlapped one another for centuries and decades. So how in the world could they be faked? All of the original authors over numerous generations would have to be in on the scam, conspiring together to record lifespans that perfectly declined along an exponential power curve. Like that's going to happen. Think about that for a minute. Why would they even want to do that? If you were going to make up some story about people in the past that you wanted your future readers to believe, why would you include such unbelievable lifespans? Making this myth explanation even less likely, whoever would fabricate this story must have understood advanced statistics. In addition, look at how the lifespans before the flood are stable. They don't follow any sloping trend line. The systematic decline only starts after the flood, suggesting that some aspect of the flood event initiated the downsloping power curve in lifespans. What was it? Dr. John Sanford explains, the mathematical nature of the declining lifespans arose because the biblical accounts are true and are actually faithfully recording the historical unfolding of some fundamental natural degenerative process. The shape of the downward slope should be immediately recognized by any biologist. It is a biological decay curve. Noah's descendants were undergoing some type of rapid degenerative process. There is now very strong evidence that humans are degenerating genetically and have been for thousands of years due to continuously accumulating mutations. This makes it very reasonable to conclude that the systematic degeneration of man that is documented in the Bible was due to mutation accumulation and resultant genetic entropy. A genetic bottleneck may well explain why mutations suddenly kicked into high gear. This occurs when a very small group of individuals become isolated from a once larger population. The few individuals carry fewer genetic variations than their forebears. They now must build each generation using less information in their cellular blueprints. Biologists have watched lifespans decline after bottlenecks in various animal populations, from dogs to guppies. The Genesis lifespan decay curve looks like real biology, which points to real history. Books throughout the entire Bible, written by different authors in different time frames, affirm this history. For example, Peter referred to the days of Noah, when 8 souls were saved through water. Shrinking the entire human population down to 8 was the ultimate genetic bottleneck in human history. This Genesis-based trend line also points to a recent creation. Luke 3 lists a specific number of generations from Adam to Jesus, and the first names on that list coincide with the names in the Genesis accounts. The smooth, systematic decline in longevity leaves no room for hundreds or thousands of missing generations. Even after watching this, many may still hold the popular but poorly defended position that ancient shepherds wrote their dreamed-up family history on animal skins, but it defies reason that ancient writers developed a text that spanned multiple generations, included over 20 lifespans that track over 2,500 years, and include 2 distinct and biologically relevant trend lines from the pre- and post-flood eras. It would be impossible to collude such a statistical phenomenon over generations. So, what are the implications that come from this? Well, for one, this shows that the whole of Scripture fits together, with several books from the Old and New Testaments referring to these genealogies as authentic history. Even Jesus himself referenced by name Abel and Noah as though they were real people. Paul also referred to them historically, and even computed time spans based on these genealogies, treating them as real history. What causes aging anyway? Biologists continue to investigate unknown aspects of aging, but largely agree that accumulated mutations within the body during one's lifetime accompany the symptoms of aging, including wrinkled skin, weak bones, and loss of immune and other system efficiency. If God made Adam genetically perfect in the beginning, then no wonder his close sons and daughters could live so long. The Bible also promises that Christ would be our kinsman redeemer, and breaking apart these genealogies would undermine the gospel itself. Christ the Redeemer had to map back to Adam as the Bible promised. These findings strongly support the historicity and veracity of the Bible, especially the book of Genesis. They suggest that although the longevity of the early patriarchs seem extreme from our perspective, it could have been normal for them. The declining lifespans of the post-flood patriarchs was due to the ongoing degeneration that resulted from Adam and Eve's fall, and were
So let's talk about the biblical narrative. Before we do that, as always, at the 10-minute mark, we're going to say the Lord's Prayer. So bow with me as we say the Lord's Prayer. Our Father in heaven, honored be thy name. May thy kingdom come. May thy will be done on earth as it is in heaven. Give us each day our daily bread, and forgive us of our trespasses as we forgive those who trespass against us. And lead us on a righteous path, and guard us from evil. In your name we pray. Amen. Amen, amen, amen. Shalom, shalom, family. So what we're going to do is we're going to take a deep look at what is the biblical narrative, and we're going to connect 2 things at once. Those 2 things is that we're going to confirm, actually 3 things. We're going to confirm that the biblical narrative is true. 2, we're going to confirm that there is a genetic and a historic, there is an actual understanding for the biblical characters, and we're going to prove that the flood happened. It's all is going to be in one video. That's what we're going to do today. All right. So first things first, we're going to at the about the end, we're going to show who is Ham, who is Shem, who is Japheth by a certain split of a chart. It's a chart that most geneticists use. Many people probably know about it. I'll just show you what it is that we're going to be using. Whenever you're looking in genetics, you want to look at one of these type of charts. This is what it is. It is called a, you have 3 different charts. You have a circular mode, You have a normal mode, which is this one. You'll see this on sometimes like family tree DNA, or you have what you want to find, which is called a unrooted chart. You want to have a unrooted chart when you're going about these things. Now, this is what's important to understand. Let me quickly just give a little highlight of this. All right, so it talks about 3 different modes, right? Normal, which is usually rectangular, circular mode, which is no circle, and then you got your unrooted mode, or another way you describe that is called a star graph, right? Or a star chart. That basically shows it doesn't have a root, right? That's why it's called unrooted. It doesn't show you like exactly what's the root, but it will show you who is related, where they break off, and who is with who. So that's very important. So we're going to be using that today and looking at the whole tree of peoples. But first things first, the first things we got to understand is that, one, the ancient biblical flood is true. So we're going to be looking at some interesting things. I'm just going to make some statements. We're going to be looking at Y chromosome bottlenecks, because remember, after the flood, there was a bottleneck. What does that mean about a bottleneck? After the flood, we only had about 4 different men. We had Noah and his 3 sons. And then from them, the whole earth was populated. So that's called a bottleneck. When you have a large population and all of a sudden that population shrinks to a size. And then from that size, you get a lot of people coming from that group, right? It's kind of like a bottle, right? When you have a bottle, you pour out, it's all going to come out that little top part, right? So it's going to be like a genetic bottleneck. Also, we're going to be looking at the younger Dryas. So some very deep things today. But first, start with this. Yeah. A little intro to something.
You have to do is have children spaced very closely together. That's very interesting stuff. And it's just really fun to apply computer models to genetics and biblical history just to see what we could do. Now, I stole this from a government website, and it's their fault. It's not the best picture in the world. But they're saying here that this is the population size over time, going all the way back to, they believe way before the Bible says the world was created. But essentially, there's about 1 million people alive across the world for tens of thousands of years. And all of a sudden, somebody invents farming. Huh. And that means that extra population can be handled because there's more food. And all of a sudden, the population does that, and we have 7 billion people today.
So food is, you can see how food is integral to living. So it's basically survival mode for thousands of years.
Yeah, but did this really exist?
No.
And how come the people with the same genes back here, who were just as smart as people here, they didn't think of planting something in the ground and harvesting it the next year? So this is really magic back here.
Right.
Taking that thought, I applied that to a biblical idea where this is the flood, this is today. And starting from those 6 people, all you have to do is double the number of people every 156 years, and you arrive at 7 billion people after 4,500 years. That's a growth rate of 0.4%. Remember, so some of my models had 8% growth rate. Now, it's ridiculous. Populations don't grow that fast, but they could, theoretically. But that is incredibly slow. And in fact, just about any model that has any growth at all, you can get this many people in those many years. So the human population size actually is a biblical human population size. If evolution was true and we existed for so many thousands of years before that, there should be trillions of people. Not that it's possible.
Yeah.
Or someone should have invented farming earlier than that. or another way to ask it is this. If 1 million people live for about 1 million years, where are the trillions of bodies?
That's a really good question.
They don't exist.
There's no bones down there.
Yeah, there are some ancient bones we found, great, but those are post-flood people. Right. There should be millions upon millions of cemeteries, old villages, and remains of people. We don't find them. I believe it's because they didn't exist. Now, looking at the Adam and Eve story, we can make some predictions. First, if we only started with 2 people, all the people today should have a low genetic diversity. If we started with millions of people, you can have a lot of genes floating around in a population of 1 million strong. But if you only started with 2 people, that restricts the diversity today. If the Bible's correct and Adam really is our ancestor, there should only be 1 male ancestor of humanity. Now, the mitochondrial DNA, the mtDNA, that's a little piece of DNA that's only inherited from your mother. All people get it from their mother. Well, that means we can build a family tree of all the females in the world, and there should only be one female ancestor of everyone on Earth today. If evolution is true, that shouldn't be true, and none of those have to be true. But also, most genes should come in two versions, because Eve was taken from Adam. She probably got Adam's genome, except for the Y chromosome. But Adam only has 2 copies of each gene, so you can only have 2 versions of each gene. Turns out, this is exactly what we have found in modern human genetics. Mirrors what we actually see in humans. It tells us there should only be a few mitochondrial DNA lines. That's Shem, Ham, and Japheth's wives.
Right.
And only 1 Y chromosome, because it's only Noah. His 3 sons would have inherited his Y chromosome. Any other Y chromosome diversity before the flood is gone. And we should have evidence of rapid population growth. We saw that a minute ago. Turns out that this is exactly what we find in modern genetics. This is the Noah's flood story also.
1 Y and only a few of the lady's genes.
Yeah.
Exactly.
Didn't have to be true. And in the Tower of Babel account, we have discovered a single dispersal of all people in the relatively recent past, traveling in small people groups into uninhabited territory through the Middle East. They call it the Out of Africa story. But these are all biblical predictions right here.
Single dispersal, all at one time, relatively recent past, traveling in small groups to uninhabited areas throughout the Middle East. That's exactly what happened.
Yes.
And the only, they think it's a little further south in Africa. You think it's a little further north. And
the starting point is a little different.
Yeah.
But the same pattern is predicted by both sides.
And they're totally agreeing with you on that.
Yes, except they want it here as far as the starting point goes.
Right.
But the Bible says this.
Yes.
Now, interestingly, I'm sure you've had people on your show talking about the biblical ice age.
Mm-hmm.
During that ice age, which was approximately the same time as the Tower of Babel, you could have walked from here to Ireland on dry ground.
Sure.
You could have walked to Tasmania.
Yeah.
And the only deep water part you have to cross is the place between these 2 little islands, Bali and Lombok, and you can see one island from the other. It's right there. It's not. And you could have walked all the way down to here on dry ground at that one point in history, not any other point in history.
It all adds up.
It does. If we look at the evolutionary Out of Africa story, that's a Tower of Babel story right there.
Okay.
Now they want to push the origin way down deep in here, but that's actually bad. The graphic artist put it there. It should be up here because this is the greatest amount of diversity. But they put it there because they can't put it there. They could not put it there. And if we just look at the history of man and compare it to the evolutionary timeline.
All right, so you see what this geneticist is saying. We're going to come back to him. So let's scroll down a little bit and have a little talk about the biblical narrative, right? Genesis 7:9-15. There went in 2 and 2, right? Remember how the flood went? They went in 2 by 2. And remember, that's also where they go in by 7s. They went in 2 and 2. And Noah into the ark, male and female, as God had commanded Noah, right? And it came to pass, there was flood waters on earth, right? And then that happened about the 600th year of Noah. It's also important to know that it rained for 40 days. And then who else was on the boat? In the self same day entered Noah and Shem and Ham and Japheth, the sons of Noah. So that's important. It's letting us know that these are 3 brothers from one father. That's going to be very important. And Noah's wife and 3 wives of his sons with them. Now that's important because we don't know what the women are related to. So we should also note that we're going to see women there, but they are going to be women from Eve, but we don't know who they are exactly related to. So they can have all types of alleles in them. And it says they enter into the ark and every beast of its kind and cattle and all those different things of the earth, right? Every different kinds of the earth. And they enter the ark, right? 2 and 2 of all flesh, right? So they entered into the ark. They settled in the ark. So what's one thing that we have to understand? Not every animal went on the ark. Not every human went on the ark. So what we need to find is evidence of a extinction of humans and animals. And we also got to find out that there was a flood around the world where there was an event that there was a bottleneck of different species, especially humans, and there was also catastrophic events. Let me introduce you to that. If you already know about it, it's a little bit the Younger Dryas. If you heard of it, let's get into it a little bit.
The Earth was hit by a fragmented comet around 13,000 years ago at the end of the Pleistocene era. And finally, scientists are now starting to agree. A new research paper has been published in scientific reports regarding an ancient civilization in what is modern-day Syria that we now know was wiped out by the cataclysm. As academics finally come round to the idea that yes, this event did happen. In light of more research like this, and modify my credence about your theory. For a lot of people, the evidence always spoke for itself, but it's positive to see him address Graham in a public manner like this. So, what have the scientists discovered? Well, remnants of glass discovered.
All right, so if you look closely on this paper that he's showing here, it talks about a very interesting culture of this culture right here in Syria. Well, we actually talked about that culture before. And that culture will actually be found in the Natufian culture, right? Now, what's interesting about the Natufian culture, it actually has something very important that it talks about. The show right here. Here's what it talks about. It says the period. Let me just go up a little bit. It says it just talks about the radial dating of those individuals and everything, pointing them to a certain time frame, right? What's important is that they are the earliest lineage of lineages. That's very important because we also have to understand that when people got off of the ark and everything, they settled about Mount Ararat, Mount Judy, and they spread out through different areas. Here's an early settlement of some of the earliest lineages that settle in the Levant. If you know Josephus, we already talked about it, how he talked about Shemites that settled in Damascus, right? Syria is Damascus. That's very important. They also found that evidence of a certain thing called the youngest dryas. Let me talk about it. The period is commonly split into two sub-periods, early Natufian and late Natufian. The late Natufian most likely occurred with the youngest Dryas. That's very important. So the youngest Dryas was an event. Just to get a quick understanding of the event, we're gonna get deep into the event. It was an event that caused warming, it caused floods, it caused all types of things. We're gonna look into it. We're gonna get into the event. But it says the Levant hosts more than 100 kinds of different things and whatnot. But it's letting you know that the Natufian transition was in between the time of the youngest Dryas. Now let's get a little more into what is the youngest Dryas, a little bit into that. Jump down a little bit down here. So about here. Let me show you something.
Story has yet to be fully
Let me
told.
show you something. I don't know why I put this like that. Let me show you something. What happens here? Let me show you a little piece of evidence of the flood that we know that connects to that event.
What's further interesting is when we look at this graph. This is the late Pleistocene mortality graph, and each square represents a fossil specimen of an extinct mammal. It could be a woolly mammoth, could be a giant ground sloth, could be a saber-toothed cat, could be the giant cave bear. Roughly 120 species of megamammals that lived during the Ice Age went extinct, right, at the end of the Ice Age. And basically, what this graph is showing us here is that you probably can't read this here, so I'll interpret it for you. If you go back to here, the left side represents 50,000 years ago. And here, where the cursor is, that's 40,000 years, 30,000, 20,000. And you see that as we're going along here, each one of these squares represents the finding of a fossil of an extinct mammal. in the fossil record. What we see from this graph is that when we get to between 11 and 13,000 years ago, there's a massive spike of mortality, shoots through the roof. This demise of these animals
directly coincides
with this right here, directly. The realization came upon researchers in the early 70s that the glacial ice, this huge amount of glacial ice, had melted so fast that they couldn't account for the energy source necessary to melt the ice that fast. And they struggled with it. There was a series of articles that basically were in the scientific literature from 1973 to 1976. And then I pretty much, after that, you don't see much about it anymore, because if you read the tone of the articles towards the end of this period, they're almost sort of giving up in desperation, saying, well, maybe there's an error in our data somewhere. You know, maybe this, they essentially just gave up on the problem. Okay, so what happened even between the early 70s, when this, what they referred to as the energy paradox, first became apparent, and now is that the problem has become even more acute. Because in the 1970s, they were struggling with an 8 or 10,000 year melt-off period. Now, with the data we have in hand now, suggests that the melt-off period did not exceed 3,000 or 4,000 years. And the second thing is, if you remember, I've shown you this graph now several times of the rates at which meltwater entered the ocean, and you could see that it was not uniform between that 3,000 and 4,000 year period. There was actually two extreme spikes of meltwater that flowed into the ocean, and which in a sense makes the whole problem that was originally posed back in the early 70s even more intractable. Because if they were not able to provide a source of energy to melt the ice within 10,000 years, how do you essentially explain the melting of the ice over two very short intervals, which may have lasted no more than a few centuries each, maybe even less than that? Is that getting rid of this mass of ice requires an extraordinary amount of heat energy. Okay, so where does such a source of heat energy come from? Well, one reason why the scientists of the 70s essentially gave up and assumed the problem was intractable was any source of energy that they were trying to invoke to explain the rapid melting. All of those explanations were all Earth-based. They were all terrestrial.
In a remote area of northwest Greenland, an international team of scientists has made a stunning discovery, buried beneath nearly a kilometer of ice. It's an impact crater, 300 meters deep, 31 kilometers wide, much bigger than Washington, D.C., even bigger than Paris, and it's probably one of the youngest large impact craters on Earth. The scientists confirmed the telltale bowl shape and central peaks beneath Hiawatha Glacier. They also found that the oldest ice in this crater was actually fairly young by Greenland standards and had experienced a great disturbance in its flow toward the end of the last ice age. The team then visited the area on foot, and in sediments deposited by a river draining out of the glacier, they found grains of the mineral quartz that showed signs of being physically shocked in a massive impact. Models suggest the asteroid was more than a kilometer wide. The Hiawatha crater is one of the 25 largest known impact craters on Earth, and the first found under any of our planet's ice sheets. Impact could have also occurred when ice already covered Greenland, and it would have instantly vaporized billions of tons of ice and rerouted the flow of ice and water into the ocean. Whenever the impact happened, life on Earth at the time would have been profoundly affected.
All right, so this has to do with the transition of basically this is what happened. All of a sudden, right? All of a sudden things warmed up, and all of a sudden you get massive floods. Then all of a sudden things turn cold, became an ice age. We're going to also talk about that because we're going to start talking about the genetics that we actually find there, right? It's going to be all involving the ice age and the genetic diversity that we see during the ice age and the expansion of humans at that time, right? So very important stuff we're going to look at. But let's get a little more understanding on this event of the youngest Dryas, right? A lot of people know about it, right? Evolutionists know about it and all those things and whatnot. But I'm going to give you the understanding of these things so that you can understand. Here's a good understanding of how it actually flooded the earth, right? Evolutionists are going to try to write it off as just something that happened naturally, right? But always remember these dates are exaggerated. This event was an event that happened all at once. So here's an example of an evolution basically expressing how this event happened all at once and how it flooded the earth.
There's continual gradual evolution over billions of years, slight imperceptible changes, but one continuous process. However, we now recognize that life was profoundly altered 5 times in the past by what are called mass extinctions. Mass extinctions occur when some cataclysmic event happens that wipes out up to 70 to 95% of all life on this planet. This has already happened 5 times, and Niles Eldredge and Stephen Jay Gould have created what is called the punctuated equilibrium theory to reveal that no, life is not one continuous progression of evolution, that there are start and stop points that have already happened 5 different times. What created these 5 mass extinctions? Well, natural events such as massive tectonic plate movements, super large numbers of volcanoes going off at the same time, or objects from space such as comets or asteroids having an impact on this planet and upending the ecosystem. As we're witnessing today, there's an abrupt change in climate that's affecting life on this planet. But this is not the first time an abrupt change of climate has affected the planet, because if we go back 12,000 years ago, when the last upheaval of climate occurred, it's referred to in science as the Younger Dryas period. I said, well, what happened? Well, if you look at the temperature charts, the temperatures were relatively cold. It was a very cold period on this planet, lots of ice all over the place. In fact, North America was essentially covered with ice. And I said, then what happened? Almost instantly, according to our record, which could have been even in one day, an event happened that raised the temperature so high that the ice started to melt. And the massive amount of ice melting led to the rising of the seas, 400 feet of rise in sea level. While we're quite aware there was some massive event changed life on this planet 12,000 years ago, there are several theories trying to accommodate how this occurred. One of them, and the predominant one at this moment, is that a comet hit Greenland, and that the heat generated by this comet coming into the environment caused a rapid melting of the ice, instantaneously causing the ice-covered continents in the northern hemisphere to melt their ice. Another suggested hypothesis for the change that occurred is that massive solar ejections raised the temperature so much on the planet that not only did it melt the ice, but it burned up the organic life that was already present. And a third, an alternative possibility that occurred 12,000 years ago was a polar shift that changed the magnetic fields of the Earth and changed the ecosystem in the process. Well, very interesting, of course, is there were a lot of people here at that time, because we know humans were actually here over 200,000 years ago. So
All right, so remember we talked about that, how we know that humans were here said a long time ago, but it's very important to understand the dates are exaggerated. How do we know? Because let's talk about that bottleneck real fast, and we're going to get back to that understanding. So remember, he just explained how that Younger Dryas, a lot of people know that there was a massive flood, right? But there were Neanderthals, Denisovans, and other different human beings in that time, right? If you know about the biblical narrative, there's all types of different things that happened, right? Some of the sons of God came down and mated with the women. But what happened, right? The flood happened. So what should we find with the evidence of the flood? We should also find a mass extinction of different human DNA. And guess what we also find? We actually find a mass extinction of human DNA. Here's an example of the dirt cave. If you know, every Neanderthal and every Denisovan is wiped out today. So that means all these lineages and all these lineages are wiped out today. All modern humans stem from one branch, which let me show you real fast what that branch is. It's going to be a branch from a lineage called A00. But there were other humans before A00. Though A00 today is nicknamed the Y chromosome atom, right? So A00 today is nicknamed the Y chromosome atom because all humans, modern humans today, stem from that male. That sounds like the biblical narrative to me. That sounds like that was a male that all humans, after a catastrophic event, wiping out all other males that existed with that one, that left the male's lineage or the lineages of the people that we see today, all connected, stemming together, but not connected to the ancient people. They will be related to them, but they won't be descended from them. Here's an example. This is the Denisovan branch, right? This will be a node, or this will be your root branch, will be the start. And then you will see a Denisovan branch. All these are wiped out. Then you will see from that branch, you'll see Denisovans, and you'll see another branch, which will be another branch. These will be actually Neanderthals. Denisovan is A0000. Neanderthal is A000. Both of these are wiped out. Denisovans wiped out. Neanderthals wiped out, and none of us come from them. Though some people are connected by autosomal, right? That's because Cain and Abel and Seth were related. And then you'll see right here, this is the lineage that we see today. Everyone today is actually going to be underneath BT and CT lineages. We'll get into that and then talk about the star graph of how those spread out. But these are going to be wiped out today. So we do have evidence of lineages wiped out today. So that's very important. So all these lineages are wiped out, but these are going to be the modern people, which you can kind of see on there. Maybe I'll zoom in a little bit so you can see it. This thing's kind of blurry, but let me zoom as much as I could. You can see right here, this is going to be modern humans. So modern humans, everyone who's a modern human is not coming from Neanderthals or Denisovans, right? This is going to be Denisovans from the Denisova cave. These are also going to be some Neanderthal lineages like El Shid-Rod. We talked about that before. We talked about some of these lineages. These are going to be Neanderthal and Denisovan lines, right? We talked about that before. All those are wiped out. But let's keep on continuing. So remember, there was a catastrophic flood that wiped out people, and we're going to also talk about that bottleneck, how the human lineage actually shrunk down to a small number.
So there was some action of humans on this planet when the Younger Dryas period hit. What was happening? Well, we have ancient stories of a continent of Atlantis, a story about a civilization called Lemuria. Well, there's some real foundation to these stories, but we have no technical evidence of where and when they existed. But something new happened. There was a finding in Turkey in an area called Göbekli Tepe. And what did they find? There was a massive city covered up, not covered up by erosion, covered up because humans actually Tigris, Euphrates rivers in the Middle East. We can talk about the loss of a civilization in Göbekli Tepe, but we can also talk about other changes. Something happened. And off the coast of Japan, divers have found sunken ruins of cities that were well below sea level. Now, this, of course, would make sense when we understand that, according to the Younger Dryas period, sea levels rose about 400 feet. So there must have been cities at the periphery of the continents that are now underwater and we can't see them. The discovery of Göbekli Tepe brings a lot of interesting questions to our understanding of the history of human civilization. But it's a very important time for us right now because there's a renaissance in knowledge changing who we are and how we got here. For example, the biggest upset of our understanding of history was the development of the Human Genome Project. For up to that point, we all believed as a fact of life that evolution was based on increasing genes and the complexity of our genome. And yet, in the results of the Human Genome Project, we find that humans don't have any more genes than some of the smallest organisms on this planet. It causes us to reconsider and review and revise history. And this is the same thing that is occurring in regard to the discovery of Göbekli Tepe. What was the point? We used to think civilization just started about 3,000 or 4,000 BC. Now we understand there were well-advanced civilizations 12,000 BC. What happened was we have lost the connectivity, making it much worse, much faster.
All right, so remember, like I said, remember looking at these things, these years are exaggerated. But that's why we're looking at the Younger Dryas, because when the Natufian popped up, they popped up right after the Youngest Dryas event, which was a mass extinction, wiping out many different types of peoples. But let's keep on diving a little more deeper to get a full understanding of this, of how the Younger Dryas had worked. Here's a little research. Let me just read you something from this. It's going to be from the Younger Dryas, right? It's just an understanding of it. It's a climate shift, right, along with changes in human culture and mega, right, extinctions, right? Basically mega extinctions, right? Here's just a little bit. It talks about it. This just gets a little, it's just a little summary review on it. It has a bunch of different things that it talk about, what happened on the earth, what happened to the wildlife, the extinctions, the climate, the cooling, how it happened in different continents. It happened worldwide. So let me just go over here. That's going to be something I'll put in the note afterwards if someone want to get a little more deeper into it. I'm going to grab something from this note here. As I mentioned this before, but let me just go to something on here. This is just a little video we went over on something. Let me just go down and go to something here. All right, so just a little understanding when we're touching on these things is that we know that a lot of these things have evidence of connection to ancient peoples and whatnot. Matter of fact, I'm gonna leave this one alone. We don't need this one right now. I'm gonna just leave that one alone. That would just have some interesting stuff in the description. Let me just go down and let's keep on getting to the summary of it all. Let's understand, how do we know that the Younger Dryas also calls the bottleneck of human species? Let's take a look at that real fast. Let's take a look at that really fast.
An extraterrestrial impact in North America 12,900 years ago.
Pause that. All right. Unless you hear this real fast.
An extraterrestrial impact in North America 12,900 years ago has been years ago. By 10,000 years ago, sheep, goats, and cattle were being domesticated in regions that had stable grasslands. During the period from 10,000 years ago to 5,000 years ago, the global temperature warmed further and became more stable. Glaciers receded and the climate became suitable for cultivation. During this 5,000-year period, the sea level rose by about 42 meters due to meltwater pulses 1b and 1c. Meltwater pulse 1b has been associated with the melting of the glaciers in northern Europe. Approximately 7,500 years ago, during the meltwater pulse 1c, water from the Mediterranean Sea spilled into the Black Sea. Such sudden rises in water level may have given rise to stories such as Noah's flood in the Bible. The rise of the sea level covered coastal areas and land bridges, thus blocking previous migration routes.
I don't know if you caught that, what he just said real fast. I'm going to let it repeat one more time so you can make sure you catch that, what he just said. He's letting you know that this Younger Dryas has perfect evidence, because what happens is after this event, you're going to get basically the time frame of our lifetime frame, and all the lineages that will exist today actually stem from this time frame, after this time frame. But watch what he says here, how he says this is also connected to the biblical flood.
Flood in the Bible. The rise of the sea level covered coastal areas and land bridges, thus blocking previous migration routes. Many of the dwellings and artifacts in the previous coastlines that could shed light on human history now rest beneath the sea. Humans evolved the ability to digest lactose in adulthood about 9,000 years ago in areas where the milk from cattle, goats, and sheep was used as a large. The stress of surviving the Younger Dryas.
All right, so now here comes the part he's going to talk about the bottleneck. So if you never heard of this, there's a Y chromosome bottleneck. There's evidence of a bottleneck. Why is there not really? You'll see that there's a Y chromosome bottleneck, and you'll see sometimes the female line looks about the same. It's because every male is from one family, right? Every male today initially came from Noah, but that doesn't mean all the women came from Noah. So you'll have still a large diversity of women, but you'll have a very small bottleneck of men, because the men come from Noah, right? Let's see a little more on that.
Surviving the Younger Dryas is recorded as a human Y chromosome bottleneck at the end of the Pleistocene. The Y chromosome is responsible for the development of male reproductive organs, and it is passed only from father to son. The paper by Carmen with 100 authors proposes that the bottleneck was caused by a global change in culture. However, the Y chromosome diversity started to decrease in all regions of the world exactly at the Younger Dryas boundary about 12,900 years ago, and it is not likely that similar cultural changes would have occurred simultaneously in regions widely separated by oceans, deserts, mountains, and jungles.
So again, did you catch that? He said this scientific event that's linked with the bottleneck of Y DNA and DNA, and is also linked with the destruction of multiple different cultures, happened at the same time. So remember, we're seeing this from multiple different points of view, but let's get the final insight on this. Let's keep on going in.
Mitochondrial DNA, which is passed from a mother to her offspring, indicates that the worldwide human population continued to increase in spite of the reduction of male population size. The difference in effective male and female population means that approximately 6,000 years ago, during the minimum of the Y chromosome bottleneck, there were 17 females for every male. This graph also shows a smaller bottleneck 55,000 years ago, when there were 6 females for every male. If the male-to-female birth ratio had remained at 1:1 after the Younger Dryas, the cultural changes proposed by Carmen would have involved the culture of killing about 90% of the male descendants of each generation to maintain the 17:1 female-to-male ratio on a global scale size. This chart puts all the different graphs together on the same time scale. The top graph indicates that approximately 6,000 years ago, the ratio of women to men was 17:1, which corresponds to the time of the greatest bottleneck of Y chromosome diversity. The graph on the right shows that the Y chromosome diversity stopped increasing in all areas of the world at the Younger Dryas boundary, but the decrease in male genetic diversity did not bottom out until 5,000 years after the end of the Younger Dryas. The fact that such a long time elapsed between the onset of the cold period and the genetic bottleneck brings up the question of whether the Younger Dryas cooling event was the cause of the Y chromosome bottleneck. This requires further research, but it is undeniable that the cooling event had a worldwide effect, including the change in human male-to-female birth ratios that, in combination with genetic drift for populations isolated by newly created geographical barriers, had long-lasting effects on the human genome. Woolly mammoths.
So you heard what he's saying. So based on a scientific method, there is evidence for a global destruction and a global extinction of species, yet not extinction as a wipeout, but an extinction as a bottleneck, as it was brought down to a small number, but then from that small number, it arose again. Let's go a little more deeper into a little bit more into that. So here's one more part to that. Let's go a little more deeper into that one more time. And then we're going to start diving into the roots and everything.
The Y chromosome bottleneck.
But what I want to show you is that the biblical narrative, one, you need it. You need it because it's truth. It's actually explaining these things better than the world's starting to find it out piece by piece. They got to put these things together. The world got to put these things together, but it's all written already in the Bible. It's already written out. So let's go about it and learn a little bit.
Water sailing. I find it difficult to believe that a global change in human culture was responsible for the Y chromosome bottleneck. The graph shows that population sizes for all regions of the world reached a maximum approximately at the Younger Dryas boundary 12,900 years ago, as indicated by the red arrow. A simultaneous global change in culture would mean that people in Europe, Southeast Asia, East Asia, the Near East, Central Asia, and all other regions of the world coordinated their culture and sexual practices in lands separated by oceans, jungles, deserts, and mountains. This level of coordination would be extremely difficult even today with modern transportation and electronic media. The decrease in effective population size for all regions in the Y chromosome graph starts gradually at the onset of the Younger Dryas 12,900 years ago. Then it dips suddenly, and it continues to decrease well beyond the 1,300-year duration of the cold event. The increase of the effective population size is just as abrupt as the end of the Younger Dryas.
All right, I'm gonna have to close. I'm gonna have to close this thing, reopen it, but I'm gonna quickly summarize this. Let me just close it and reopen it. All right. So let me just turn my screen share back on. All right, so what I just showed you real fast, let me quickly summarize this last piece. So remember how we was just talking about the Younger Dryas? This is an illustration of the Younger Dryas right here. There's going to be the Younger Dryas. And he's also connecting it with the bottleneck of the Y chromosome. So there was a bottleneck of human species at the exact same time of this Younger Dryas event that caused a catastrophic flood. It's also showing a massive wipeout in species worldwide. So that's very important. So that's what we just summarized real fast of all those things I just showed. Now we're going to start getting into the understanding, right? Because we just verified that, yes, there are some, the biblical narrative is truth. One, the biblical narrative says that God made all things and he made all men and women from one species. From based on this root, even the Neanderthal and the Denisovan ancient humans are all related. All humans came from one, basically ultimate human. But there was a new Adam. Who would be the new Adam? What would be the new Adam? Noah. Noah would be the new Adam. Not the new Adam as in Christ, who's the new Adam, who is our true Adam. But the new Adam that basically after the flood, everyone basically split from. So that will be where you will see when I say your Y chromosome Adam, you can type it down and find it without a doubt. Y-E-N-A Adam, right? It's not just a biblical term, it's a real scientific term, right? You'll talk about your Y chromosome Adam, and that Y chromosome Adam would be necessarily A00 is what they actually would find it to. So they'll just talk about right here, Y chromosome Adam, right? We all know about there's a Y chromosome Adam, there's also a mitochondria Eve, right? There's a Y chromosome Adam, there's a mitochondria Eve. All humans today, all modern humans today, not Neanderthals, not Denisovans, but all modern humans today stem from those. So that's going to be very important to understand as we move forward, because we're going to go to the roots and we're going to point out the exact root. Now, for pointing out the root, we need to use a star graph. That's going to be the first thing we need to do. But what's important about a star graph, if you already know, star graphs do not show you the root because a star graph is unrooted. That's very important. That's the point of a star graph. It has no root. So we have to find something that's going to go into the depth of the star graph. We're going to need that. Now, we already went over the understanding of these families, but just for the sake of being basically neutral, let's just establish three splits. I'm not going to say who is Ham, who is Shem, or who is Japheth yet, but we're going to establish three splits on these lines. Now, this is going to be from the 1,000 Genome Project. The other guy who was just seen, he was just talking about this project, the 1,000 Genome Project. The 1,000 Genome Project was basically establishing how all humans in the whole world are connected. We all root to one root, but remember, this is unrooted. So that means you don't see the root here. It's going to be stemming out, but every single person haplogroup is on this branch. But the way that they're connected, we already have some what's called a monophylactic group. Mono meaning one, phylactic meaning family. One family. We're finding one family groups, right? There's going to be monophylactic, just a Greek word meaning one tribe or one family. So right here, you'll see an F that encompass this whole thing, and then you'll see a transition of a K that encompass this whole thing. That's going to be important because we're going to look into the roots of it. Let's look into the roots of it. First, let me read you a book, right? When they was talking about genetics and everything, here's just a quick summary of the classic breakdown of genetics after Y chromosome Adam. So referred to as Y chromosome Adam, we all know, we already talked about that. In the chromosomal tree of all mankind, the first basal branches are represented by the many subclades of parental, that's the Y-DNA lineage. The important clade BT, right, represents a subclade of one, just basically one of the branches, and there's other branches we're going to look at. So the main one we want to look at is the parental branch BT, and split into the branch B, and then CT. So we want to know, how are these splitting? How are these dividing? So we're going to know how these things are splitting, how these things are dividing, just to get a little understanding on that. Let's go down and actually get into the actual breakdown of these things. So let me first go down here. Here's going to be a tree. There's going to be a very important tree. Remember how we was looking at this thing over here. Once the little thing opens real fast, get back to the unrooted chart. Or not that thing, right here. I'll move this right here. All right, so remember this unrooted chart. So you see that F? What's important is you'll see with a quick understanding that from this little site right here, we're going to get a quick understanding that this tree is going to have important roots. It quickly gives us an understanding, and it says this about some of the roots. Let me just go down a little bit. It says the left branch represents haplogroup A. So the left, on the left, right here. So the left side is right here. So that left branch is haplogroup A. That's important. And then it goes down and it says this on the left, haplogroup A, and it subclades. The right branch represents F through R, including T. So you can see right here, on the right branch, you're going to see all the way on this side, which is the right, is going to include F through R. So R right there. So F through R. So it's going to be, we're going to actually have to note what these splits are. That's going to be very important. We can actually know by just reading right here. It says the tree shows the alpha haplogroup. Alpha haplogroup means it's the ultimate split. It means what you're seeing is a split, which you won't see on an unrooted chart, which right here, you don't see the BT or CT on this chart, but you can see that you can see a B here and you'll see a C here. And then over here, you'll see T. BT, CT is just mean it's all groups under C and B and all the way down to T is what it basically means. It's just every group. So there's a center group here, and that's what it's talking about here. It's talking about a center group, which is going to be BT. It's going to be very important. So the right branch of haplogroups F through R include T. They say that they're basically one family. They'll say they're Europeoids or Caucasoids that rose about, they'll say this long ago, but we'll just say that about the same time, that they all rose about the same time. And then they talk about B will rise up, and then C will rise up. And then you also have a different lineage that rose up at the same time, which would be the Middle Eastern haplogroups D and E, which split 42,000 years ago. Now, we're going to talk about that too when we start breaking down what these are and everything. But it does show us splits. It's talking about splits now, how you got different families, right? And if we was to put them on a star graph, what it just explained was exactly this. It told us this, that on one side of the branch, you're going to have a group from F through R. On another side, you'll have C. And on another side, you'll have A and B groups, right? Remember, we already established A was one group, and then also B is another group. And then on another side, you'll have E groups. So initially, it would actually, in a way to draw it out simply, let me just draw it out really simply here. Just grab the paint tool here. This is what it would basically look like. If we had a star graph, this is how a star graph looks. It goes out like that. It goes out like that. This. It has no center, right? If it was a rooted chart, it would have a node. This would be a node. And let's say you'll have like a B here or A here, and you'll have what is called a root. This will be a root. That would be a root right there. Just this part right there. That would be a root. But on a star graph, you don't have a root. So you don't have a centerpiece. They all are it's just letting you know they're connected, because we don't have Noah, we don't have Adam, we don't have a lot of ancient people to have a root. That's very important. That's why you want to use a star graph, because we don't have those exact individuals. But what it is explaining to us is this, that on one side, we have a group, right? And on another side, we also have a B group. We're going to find out which ones are what is called monophyletic, one family. We're also going to have on another side a D and E group, right? We're also going to have on another side a C group. And we're going to have another side F through R. So I'm going to put right here F through R. So that's going to be very important. So remember, at the ends of these branches, they all split off like that because there's going to be different ones that come off from one of these stems. But it just told us the main stems. These are the stems. These are going to be what you're seeing here is the ultimate. If you were to simplify this right here and make them all like basically under one stem, it would look like this. This is what it would look like. You'll have A and B groups, you have D and E groups, you have a C group, and you have an F group that makes everything underneath it, which is R to T and whatnot, J's and all that. They're all one underneath that F. That's going to be very important. So that's going to be very important for the star graph. So that's what we're seeing on the star graph. So you can see right here, this is a more detailed version of it. So you got your F and your R. You can see all the other things that come from F on this side. Just zoom out. And then you got a C, and you're going to also have your B and A groups. And you're going to also have your D and E groups. That's going to be very important. Which ones are monophylactic, which ones are connected. So it's letting you know which ones are connected, which ones are monophylactic, which ones are going to be coming from who. We're gonna talk about which suns they are and everything. And how many suns do we have so far? It almost looks like we have 4 suns or even more. But rather, when we make them monophylactic, we can make them 1. Let's first start with A and B. The thing about A and B is that A and B were 1. How do we know? We got multiple ways of knowing. Let me actually open up a note and show something real fast here. We know also because other geneticists had talked about it. One of those geneticists early on was actually Dr. Nathan Jensen. He actually talked about how A and B were 1. That's very important. But Jensen actually made a mistake. He started to focus on the time scale. See, this is the thing. When you see these time frames, don't be scared. Don't say to yourself, well, it's not exactly pinpoint. Is not something that I can trust, right? Let's not try to focus on trying to bend the time scales, but let's understand what is actually making sense to the biblical narrative. So we got evidence of a flood. Though the time frame may seem a little off, but we do have exact pinpoint evidence of a flood event and a mass extinction of humans. Now, let me show you something real fast. Watch what Jensen says right here real fast.
There eventually will be 3 major lineages, S, K, and M, Papua New Guinea, Australia, so forth. They're all 1 at this point in history. In Africa, there is a division in lineages.
Note what he says here. This is what's very important. This division is 100%. These lineages are never connected because there's going to be a separation at what is called CT. Before I play this, let me just go over here and talk about that. So what we have to do, we're going to have to open up this note here. Just go down a little bit, and we're going to open up the note to this right here. I'm going to actually open up a PDF of it. Right. All right, so let me show you what I mean here, what I basically mean. Let me just put CT so I can show you what I mean. All right, so now if you've seen on certain pages like Family Tree and things like that, you'll get a quick understanding of it. But let me just type it down here so you can see it. Or I might just open up it on Family Tree, because if I type CT, I'm sure it'll give me a large list like that. Let me actually, here, I'll open up it on Family Tree. Just to show you what I mean before I proceed. There's a lineage called CT. And underneath CT is not A and B. That's very important. Underneath CT is not A and B, but it's going to be a split. Underneath CT will actually be CF and DE. That's very important. Only 2 lineages are underneath that, but there's almost 19 different lineages that come from those 2 lineages. There's a lot of different lineages that come from just DE and CF. Let me show you what I mean. And we're going to also show you how the way that they actually break is very detailed, very important. So right here, CF, and then DE. So remember we was talking about that, how there's a split as C and F, and then there's your D and E, because actually there's a lot of different stems of this. So you can see even like right here, you can see D has a stem and E has a stem, but they were ultimately together. And A and B has a stem, but they were ultimately together. But A and B is different than D and E because they split. You can see how A and B is connected with the C, but they split there. That's actually going to be a split at these two lines that are touching right here. These two lines that are touching is actually that centerpiece right there is your split. It's actually going 4 different ways. It's going this way, it's going this way, it's going this way, and it's going this way. That's very important. It doesn't actually, you can't just circle this and say they all stem this way. You got to understand the way that it's actually splitting. So it's going 4 different ways. It's going this way, it's going this way, it's going this way, it's going this way. But some of these are what's called monophylactic. We're going to talk about that. But getting back to over here, you can see under CT, you're going to have DE and CF. So DE never starts off with A and B because it splits at CT. That's very important. And CF doesn't start off with A and B nor DE. Those are going to be a separate individual lineage, right? A and B doesn't make any of the, like, for example, if we was we'll get into it. We'll talk about it as we keep on going with the star graph. It's going to be very important to understand as we talk about these things. All right, so let's get back to this one over here because I want to show you on the way that they root. Let's go to A and B first, and let's take a look at A and B and how they are connected. So let me zoom out a little bit. All right, zoom in a little more. All right, so this is going to be a detailed version of the tree. So remember how I said A and B, right? They're actually going to stem. This is going to be a root. We don't know the root, but this is going to say that it has a root. What they do is that they stem, but notice that they're connected. They're going to be connected, but really the way that this is branched, remember how a tree works. There's many different ways to draw a tree. I have a video that I had talked a little bit on it when I talked about there's many different ways to draw a tree.
The Y chromosome bottleneck and the young.
Pause that. We'll get back to that. But there's many different ways to draw a tree. You can draw with these corners, but you see this corner right here? That means nothing. The corners mean nothing. You can literally take a line and go straight to here because those corners don't mean anything. And when you see these trees, because usually you see that in what is called a normal chart, not in usually a unrooted chart. So that's going to be very important. But let's go back over here. So you see these corners, this corner, you can literally go from this root and go straight down like that. And have different branches that stem. Like it'll be straight down. This will be a stem. This will be a stem. You'll go straight down. This will be a stem. You'll go straight down. And this will be a stem. So you see that CT? That CT is going to be a separate lineage than A and B lineages. That's very important. A and B is not the same as CT because they're going to be separate at its root. So the root lineage, there's no A here or A here or A here that's making this CT. That's very important. But the A's are over here. Let's get a little more detail into it. Let's look at a little more detail on the tree. So here it is, turned as a tree because trees start at the root. So this is why it's called a tree because this will be your roots in the ground. And then up here will be your branches, right? It will be your upper branches, right? So different branches. But notice, right? Just like a tree, a branch that's far away this way won't put the leaves on the branch that's far away this way. Again, a branch that's over here will not put leaves or add a branch to a branch that's over here. That's important. That's extremely important. That means A and B are going to be different than CT. We'll also read about it and understand that that's true. Let's go down a little bit and get a little more detailed picture of what you're seeing here. So what you're actually seeing here, let's actually see what it is. This is what you're seeing. Here's a zoom in on it. So this is like what this basically is a star graph with its nodes. A node or a clade is basically counting ancestral lineages that are connected at root lineages. It's kind of like, let's say if I had a son, right? And he had a son, and he had a son, and he had a son. All those will be connected to me ultimately, right? It's kind of like for a biblical narrative, right? If you know about the biblical narrative, you already know about Ham, Shem, and Japheth, or you already know about Abraham, right? Let's talk about genetic Abraham. He has Levi, Judah, and let's just take Levi and Judah, right? Ultimately, they're going to be related, right? But would you say that a son of Javan would ultimately root to a son of Abraham? No, because if we were to take a branch from another line, they wouldn't be underneath another line. Well, we'll explain as we go on. Let's understand what's going on here. So just to understand what's going on here, just to make it understood, I already went over this little picture, so I'll just quickly tell you what these two pieces are. This A piece and this B piece. This is actually BT. Right here is actually BT, and this is actually CT. This is actually CT right here. What's important is what it tells you right here. The tree at the top shows the series of African haplogroups split 3 times in a row and depart from the non-African haplogroups. That's important because they will count the CT as basically being non-African. That's very important. That's very, very important. But watch what it says here. The non-African haplogroups, BT and CT, because they're found outside of Africa, we can also show those in the fossils, do not descend, right? This is very important. Who do they not descend from? This is what geneticists have found out. BT and CT do not descend from the African ones. Which ones are the African ones? Let's quickly give an understanding real fast on some highlights of the points that it's talking about here. What it's talking about is A00, right? If you've seen a tree, if you go to like family tree or anything, it'll talk about this group called A0T or A0 or A00, whatnot. But watch what it says about A0T, right? It starts rather, right? If you talk about the tree from the root, it starts rather at the evolutionary trunk of the human Y chromosome tree. Now, understand this is not based on evolution. This is based on monophylactics, how people are connected. So it's just going to be talking about how they're connected. There's no throw-ins of monkeys on this or nothing like that. It's just talk about modern humans, how they're connected, how families are coming from each other. So let's talk about A0, just letting you know that A0T is actually A1B. So sometimes you'll see different names like that, like A0T, but it's actually A1B. So it is now A0, right? According to the new function, pretty much. But watch what it says here. Watch what it says here. In other words, we see a departure of a first African branch, A0. So A0 is African. That's very important. From the main tree. Note what it says here. None of the non-African groups, haplogroups CT among them, descend from that departed haplogroup A0. Because the Outer Africa design doesn't want you to believe that we all came from one man and one woman later on. This is what I mean when I say that. The Outer Africa design doesn't want you to believe that there was a mass extinction of humans and that there was a flood event and we all got off the flood and we're all related in that way. It doesn't want you to think that. It wants you to think that the A groups actually made everyone. Because what that would do is actually cause the biblical narrative not to be true. Because the biblical narrative says there were 3 sons and everyone today is actually not going to make each other. That means no one today makes anyone else today. That's important. Well, let me explain that a little better. No one today, all the way to their root, right, makes a different makes everyone today. There's no ultimate root lineage of people living today that makes everyone today, right? Let me finish reading and I'll explain what I'm saying. What's concluding here is that A1A, even A1B, and other groups, right? A0, A1A, A1B, just to give the highlight of it, is basically concluding this. This is what it's concluding. It's concluding that basically it does not. So it's talking about CT and everything. Let's talk about CT. It's letting you know that none of BT or CT lineages descend from them. That's important because that means that what we're actually looking at are Ham, Shem, and Japheth's sons. Not that we're looking at. This is not what we're looking at. This is what evolutionary wants you to believe. They want you to believe that. This is what they want you to believe. Let me draw it out. This is what they want you to believe. They want you to believe that everyone began as an A group, right? And they want you to believe that a DE came from that A, right? They want you to believe that a D and an E came from that A, as well as CF came from that A. That's what evolution wants you to believe, that the A group ultimately made these lineages, but that's not actually what we see. Rather, what we're seeing is that we have to take this by a unrooted chart, that we actually don't have Noah or exactly Adam, so we don't have a real root. We don't have the fossils of them to say that we have their roots. So that's very important. So we don't have the exact genetics. That's very important. But we do have the evidence that we all are related. That's important. That we all have a ultimate founder. That's very important. So we all don't come from A because A doesn't make CT. That's very important, but let me remove that. All right. So let's go back over here. So it's basically concluding that A doesn't make these lineages. A doesn't make these lineages at all. That's very important. Let's go back over here. So that's why it says, again, what it's saying about this right here and here, just to know that this is CT and this is BT, let you know. Right here, just let you know about the tree. Talks about the split and everything. It says that non-African haplogroups, BT and CT do not descend from the African ones. So very important. So people didn't come out of Africa, because we did a video on that, on how they actually found those A groups outside of Africa. Because if you know the story with Nimrod and stuff, we'll get into it and talk about some of those things with the A group and how we know who they are and everything. The A group is one group that's going to be different, and they're found in places, sometimes in Africa, the earlier ones in Africa, but sometimes outside of Africa. But they also don't make everyone. That's not how they work. But rather, what you're seeing here is actually showing you what is unrooted. Let's go up and get more closer into what's going on here. So now we know that A and B are actually connected by this CT. This CT and this BT actually connects A and B, but different, right? Because BT and CT are actually the roots. They would actually be the root lineage, but A and B would be together. So you can see right here going up. So you can see going up here. Right here, you'll see CT right there. And this will be your A and your B lineages. This is what it's concluding, that A and B were ultimately one. As you can see, they would connect at one node right there. They will be A and B were ultimately one, but CT will not be. So here's just another confirmation from a geneticist, from what he says about it and whatnot. Let me see.
Many Bible readers feel puzzled when reading the genealogies in Genesis.
Close that real fast. We're going to come back to that. I'm going to close this one. Make sure not too much things are open. Right? Now, watch what he says here. Watch what Jensen says here real fast.
But some of the major ones are still joined. A and B are separate from D and E, but A and B have not yet separated.
You heard what he just said there? This is something that when Jensen said this, that was right. When he said A and B are separate from D and E, he ended up backtracking. The reason why he backtracked, if anyone knows, I'm going to tell you the truth, why he backtracked. He was way too focused on making the timeline exactly 4,500 years old. Now, I understand that the biblical narrative is true and those years are true, but the problem is, if we take in the factor of the Neanderthals, we cannot force the timeline. You hear what I'm saying? We can't force the timeline. And actually, that's many other geneticists had already talked about that's what Jensen did. He forced the timeline. It's because what he was using, Jensen has a clever design. He has a design that actually can change fossils, but at some point he stopped using fossils and he started to rely on, well, this is what it is, so this is what it's going to be. But if you take the fossils, he forgot to use multiple different fossils, like the Gossulian fossils. He forgot to use the Natufian fossils. He forgot to use many different fossils for E and T. Those are going to be very important fossils, Gossulian and Natufian. But this is how he changed it. Let me just explain how he changed it. If you see a fossil, sometimes we go over fossils that are extremely old, like Natufian fossils. Sometimes they're in the 9,000s, right? 9,000 BC. That's about 12,000 or 10,000 years ago. What's amazing about that is that Jensen knows how to basically convert that to the biblical narrative. We also did that too. If you ever seen our video on the Natufian, we know how to convert the Natufian time frame to the biblical time frame, because at the Natufian time frame, which would be about 9,000, about that for the fossils, they can be converted to about 2,000 years on the biblical time frame. But the problem is Jensen ends up basically, what's the word I'm looking for? Forcing splits, and he'll have certain family trees that kind of look like something like, let me just show it this. Now, the problem with that is that he ends up forgetting, what's the word I'm looking for? What makes what? That's what I'm going to show you today with the scientific method, what actually makes what, right? But before we even say who's Ham, Shem, and Japheth, let's first establish the splits. So we already got a star graph, the simplification of a star graph, and we know that A and B started together. So we know that A and B, make a better circle there. We know that A and B groups started together. We haven't yet established who are A and B groups, but we will definitely establish it, because we're going to bring out historical documents and we're going to show the 4 sons of Ham. We're going to show the 7 sons of Japheth, and we're going to show the 5 sons of Shem. So we're going to talk about that. So remember, A and B were one. So A and B were ultimately one, just like Jensen said. But remember, you got to be careful on some of his work. So that's just something to note. Let's go over it one more time where he says again about A and B and D and E, right? Don't let him backtrack on you, but let him give you the truth of what he's saying here.
Ancient. In the Pacific, and this is something we talked about in episode 16, there eventually will be 3 major lineages, S, K, and M, Papua New Guinea, Australia, so forth. They're all one at this point in history. In Africa, there is a division in lineages, but some of the major ones are still joined. A and B are separate from D and E, but A and B have not yet separated. D and E are one lineage. Of course, D is not going to remain in Africa, except at perhaps a very low frequency. It's going to become the peoples of the great Andamanese Islands, the very dark-skinned people out here, and Japanese.
So Jensen right there, he does okay for the monophylactic groups there, but what he does, he's not using fossils for where D and E is actually located. The oldest D and E is actually in the Middle East. That's why that paper has said it when we went over it. Not gonna make a big deal about it right now, but we'll talk about it when we talk about where did A and B and D and E, a lot of these lineages, where do they actually sit? Where do they actually stay at? Because the oldest D and E, we'll talk about those things and whatnot. But let's establish these things. So remember, D and E was together. We also seen that on the note. Let me make sure we look at that again up here. So we seen that one more time for those monophylactic families. So remember how we talked about those nodes, those splits and everything. And then we can note the monophylactic families. Here's how we're going to understand it. Also, I'll quickly point it out. Here's the monophylactic families, A and B, C, which you can see right here. That's one node, C. And then you also have D and E. Note that D and E, note where they're connected at that node. So D and E, they're connected at that node from CT. And then you also got right here, F through R. So F through R. So F through R. Very important. That's including L and T too in the midst. But let's talk about what's those families real fast. You can see right here, the left branch represents A. So A is one group, which we know was connected with B. It says the right branch, we can see F through R, including T, which are one group. We also can see B, which is going to be one group. It says it migrated into Africa. That's important because we'll talk about some things with the Cushites and things like that. And then you also can note C. C is one group. So C is going to be another group. What's important is that they also know that these are, the monophylactics are going to be one, but they are going to be, what's the word I'm looking for? They're going to be families that we can put on a chart of Ham, Shem, and Japheth. We'll do that in a second. Apparently, and we can see right here, apparently, based on fossils, apparently, Middle Eastern haplogroups D and E split 42,000 years ago. So remember, these dates are exaggerated. That's very important. But we can see right here which ones are monophylactic. Which ones are monophylactic? Remember, we confirmed A and B are connected. So we got those connected. We know that F is connected with T and all these things. We're going to also end up connecting it with C. We're going to connect F with C when we start looking at certain connections. But we also know already that D and E was ultimately one. Very important. Those things are going to be very important as we proceed forward on these things. Let's go and look more into it. So, and we can also see that on a star graph. So you can see right here, remember how we know F is going to make all these lineages. We also know that by the root of the tree. You can see right here, CF. This is how we know they're one, but we're going to also show how they're one by a source. You can see right here, CF, CF-P143 is a fossil. That's very important. CF-P143 are actually fossils. We'll talk about that too. C comes from CF, and also F comes from CF. But This F is very important. You got to remember this name, F-M89. If you're any of these branches underneath here, G, H, I, J, K, R, all those things, right? You got to remember F-M89 because F-M89 would be a grandfather of all those lineages. How do we know? We got a couple different sources how we can actually explain how we know, but one of the best ones I think is from geneticists themselves. Here's the answers from geneticists themselves on what they say about those groups. I'm just going to read you a couple things, but before I read those things, it's important to know what is a monophylactic group. So here's just a definition of a monophylactic group. A monophylactic group, sometimes called a clade, because if you look at what's interesting, if you look at the family trees of Ham, Shem, and Japheth, you know what you're actually seeing? You're actually seeing what is called monophylactic families, or one tribe. They're tribes. So this is actually going to be a list of tribes. Let me see if I can just open this in a new tab here. All right. So this is going to be one tribe. So what do we mean by monophylactic? That means basically this is how you say something is monophylactic. Kittim and Tarshish is monophylactic with Javan, right? They're all monophylactic. They both will come from Javan. And we also have things like that from other groups. But let's go over here so that we can get a little more dive into it. Right over here. All right, so monophylactic group, sometimes called a clade, including ancestral taxation, or how you say that, and all of its, note what it says, and all of its descendants. That's very important. That means that the father clade or node or the parental lineage that brings those lineages would make all descendants under it. Very important. So very, very important. And we can get other places that we can see it also in common descent. That's another way to describe it. Common descent. They have a common descent, right? Levi, Judah, Benjamin has a common descent from Abraham. Different ones have common descents, things like that. Monophylactic group can be separate from the root with a single cut. That's important. What does that mean? That means this monophylactic group this is one monophylactic group. They're all separate from the root, which great. We're not using a root on this unrooted chart, star graph, but it's separated by a single cut, right? These are two separate lineages that later separate. This is a single cut. That's going to be a monophylactic group. Can be separate from the root with a single cut, whereas this is very important. Non-monophylactic groups need two or more cuts. What does it mean by two or more cuts for a non-monophylactic group? Let me show you what I mean. What's a non-monophylactic group? Here's an example of a non-monophylactic group. Let's say you're trying to connect something like, let me go over here. Let's say you're trying to connect something like, this is something, I'll even use Jensen for example. Let's say you're trying to connect something like this. Let me show you. And I'm going to show you that is actually something that geneticists know, and they call it the term counting steps. It's called counting steps. Let's say you're trying to make a G and a H and a G related to D and E. Let's say you're trying to do that. Is that monophylactic, right? Is H and G and D and E under one node and no other family? Because what's also important about monophylactic groups is that it also includes the definition that it makes the family that's underneath it, but not other families. That's what makes it monophylactic. But let me show you what it means if you're doing something like that. Let me show you what's going on when you're using multiple or non-monophylactic group. Let's say you take G. Is there one split that's going to take you right to DE? Or are you ultimately going to, if you was to close a node, can you have one lineage? I don't want to make it too confusing, but you can see here, if we was to see G, we know that DE is in here because DE has another stem. This is where it's stemming from, down here. Let's keep following that stem. You can see that stem going down, 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 right there. So DE is actually not monophylactic with G. That's actually very important. G and D are not connected by one node. Here's something that's connected by one node. We can say IJ and K are connected by one node. What is that node? We can close it and have one node, IJK. So you see how they were all related to one node? That's monophylactic. That's an example of monophylactic. I close one tab and that would have me with one families. Even though it's a lot of branches, they're all monophylactic with one node or one clade, right? Connected by one taxation, or how you say that. Right here, you can see CF is going to have its own lineages. DE is going to have its own lineages underneath CT, which remember, A and B do not make these. Very important. So CT, note that CT. Keep your eyes on that CT. That's going to be your split. That's your real ancestral lineage. Might even be leading you to Noah. So that's going to be your real ancestral lineage. Very, very important, right? Let's go back over here just to get back to the understanding. I want to fly over anyone's head, try to make it understandable. Okay, so this is what monophylactic mean. Of a group of organisms descended from a common evolutionary ancestor or ancestral group. That just means that a father to a son. That's all that it means. Is that it's basically a monophylactic group is how the biblical narrative works. That is going from father to son to father to son. Especially, this is what makes it, and this is what really makes it monophylactic, right? Is of a group of organisms descended from a common evolutionary ancestor or ancestral group, especially, this is what the most important part is, especially one not shared with any other group. What does that mean? If, for example, let me show you something. Let's say we take Jeans' type of design and he says G and H are actually connected with D and E. Is G and H connected with IJK? Is G and H connected with IJK? Absolutely, because they're connected by one node, which is this. This is their node. So G, H, IJK, all those lineages are actually one node. So it technically wouldn't be monophylactic if we had this design. So you see right there, H, G, and F actually they're going to be connected with these because F actually makes these. That's important. But what it doesn't make is these. How do we know? Let me show you what a geneticist say. How do we know that F makes IJK or GHIJK, but not D and E? Because that's how a monophylactic group. This is what a monophylactic group looks like. This is how you know when something's monophylactic. When you can take one node and close it, and everything's underneath that node. That's monophylactic. This is when it's not monophylactic. If it's like this, if you're taking one node, here's a node, that's going to be a node, so it still has a node, but what's not happening here? Some of the lineages are not underneath that. It's like taking GH and putting it with D and E. So, for example, here, D and E with F and maybe not IJK and stuff like that, even though they're under one node. That's not monophylactic. That's this. And this is a different one. This is taking one node and another branch from another node. That's actually what Jeanson did. What Jeanson did, he actually took, and you can actually see it from his stem. You can actually see it from his stem that he would actually have a branch here. And I don't know, he just throws it on however he wants to, which makes no sense. But you can see right here, let me show you what I mean. Let me just go up and show you. This is what basically he did. He took an F and a G and a couple things like that, and basically connected with DE. But the problem with that is that that's one node, and this up here is another node. Because remember, what did he tell us? D and E started together and A and B started together, right? But D and E never started with GHI and all those, or GH and F. Those never started together. That's very important. So that's called counting steps. That's an example of counting steps. But these are going to be monophylactic. These are going to be monophylactic underneath one node and underneath one node. Let's go back over here and understand what I'm saying here. We're going to confirm it also with a geneticist. So you can see this is going to be a monophylactic group when it's counting every group underneath it. Let me show you what that would be like. If you was to do it wrong, this is what it would be like on the biblical narrative. It's like saying, here's a son of Shem. Here's all the sons of Shem. Elam, Gomer, and Ashkenaz are sons of Shem. Do you believe me? No, absolutely not, because that's not monophylactic, nor is that how Gomer was born. Gomer was not born of Shem. That's what it's like. Taking a G and a H and connecting it with D and E would be that same way of taking a Shemite and have them making a Gomerite. So that's what it means by counting steps. If you understand a biblical narrative, you know what I'm saying when I'm saying counting steps. But let me also confirm it to you with a geneticist. So let's confirm it. So let's go over and talk about it over here. All right. So here's a question I asked a geneticist. I'll show you the question, and it has to do with monophylactic families. So I must ask again, as I seen the tree on the site, I seen a second professional. I need a second professional confirmation because I already talked about this with a geneticist. I was talking to a geneticist on WhatsApp privately, having a conversation on how these monophylactic families work. And I just want to get a second confirmation for everyone to understand it. J1 and T haplogroups are from IJK. Is all haplogroups like GHIJK related to F-M89? F-M89 was the living grandfather of all lines under it. I'm asking, is haplogroup F the grandfather of groups like J and K groups, right? Because that's important. K groups just means all those under K, right? Just to show what I mean, all those under K. Right here, you can see K at the bottom here. All these are under K, L, T. So I'm saying it are J groups, which are under F, also related to K groups, which are also under F, but under K. So that's what I'm basically saying. So this is what they say. This is going to be from a big Y specialist, information specialist. This is what they say. So thank you for contacting Family DNA. Haplogroups J1 and T are downstream of haplogroup IJ. You are also correct that F-M89 was the ancestor of GHIJK and all other branches downstream of that SNP or that SNP and haplogroup. So you could say the original progenitor, right? Remember how we talked about that? F through R are related. The original progenitor, right? The original progenitor of the haplogroup F is, however, many great grandfathers of haplogroup J and K. That means if they're the grandfather, right? If we put down the biblical narrative, what does that mean? If F is a grandfather, what does that mean? That means F has to come from one father, right? F's descendants, J, K, G, I, they all have to be one branch from one family. That's important. We'll get back to there, and we'll talk about that when we start showing Ham, Shem, and Japheth. We haven't talked about them yet. Who's Ham, Shem, and Japheth? We'll just talk about roots. So again, grandfather of haplogroup J and K are downstream of F. And descend from the man. That's important. It's not just letting you know that this is just some scientific method that is saying. Now remember, all these names, F through R and all those names and whatnot, is just things that they're given to areas of the Y chromosome that basically don't go to recombination. I'm not going to make it too complex, but it's just names that they give to certain areas that they know are connected by certain mutations that basically connect by certain SNPs. Long story short. So they know that it's actually connected. It says the man who first had F-M89 mutation. So remember how I said you got to remember F-M89? That's why I said F through R. F makes everything from all of these all the way to what's under P, which is R and Q. So underneath P, you're going to see basically R and Q, which I'll probably overlooked real fast. Somewhere up here. One of those right here. So under P is your Q and your R right there. So all those are going to be underneath F. So F is one family. That's very important. Let's get back over there and get a little understanding. So you can see right there, he also, F has other sons, other F groups, right? With other F groups and whatnot. Let's go to another, let's have another specialist, see what they say. Here's Robert. Here's how we know. Remember how we said, what is a monophylactic family? A monophylactic is basically one node that makes all branches underneath it, but not other branches. Here's how we know that it's actually monophylactic, right? F-M89 makes all lines of IJK, correct? And he basically says, obviously, he says, you can see it on our haplogroup, public haplogroup tree. IJK descend from F-M89. They're not trying to hide the information. The information is there. So here's a perfect question. This question is exactly a monophylactic question to know if it's actually monophylactic. Watch. Yes. Then it's correct to say F-M89 is a grandfather of IJK, but not, this is how we know it's monophylactic, but not A and B nor D and E haplogroups. And the geneticist says yes. Why is that important? Because we just confirmed by the definitions. Let's go down a little bit and talk about that definition one more time right here. How do we know something is monophylactic? This is how we know. Monophylactic. So this is going to be, just to show you that this is the definition, right, from the lexicon. Talk about what is monophylactic.
Monophyletic.
Right? So again, of a group of organisms descended from a common evolutionary ancestor or ancestral groups, especially, this is where it gets important. I don't know what just happened. Let me close that. Right? Note that especially one not shared with any other group. That's how you know it's monophylactic. Because, for example, look on this. You see how this one is excluding one group, and this one is including one group. So if it's including one group that's not in the node, if it's excluding one group that's not in the node, it's basically paraphylactic. That means like partial, basically. And if it's including a group that's not in the group, right? If it's including one group that's not in the node, then it is polyphylactic, right? Like polygon, multiple sides, right? Polygon, multiple, right? And para just being one, or basically small, basically broken. Mono meaning one, all complete, a complete group. So remember, we just seen that the geneticist, one more time, he said right here that F actually makes all the IJK groups, but not A and B nor D and E, right? And that by definition, by scientific definition, right, that is monophylactic, especially one not shared with any other group. That's very important. So what we just established is exactly the monophylactic divides of humans, and also the evidence that all these things fit with the biblical narrative perfectly. It's something that we can all understand and come to a good understanding of. Now, let me go down and just show you something here. So we do have the root splits of CT. We do know that CT was a early lineage of different lineages, but I'll just show you first the fossil of CF. We do have a fossil of CF, right? I'll show you first the fossil of CF. So let me just find it on here. And that CF that we want to find is called CF, right? Let me actually show it right here. It's not just any CF. It's exactly CFP143. We want to find exactly CFP143, which is going to be one family. If we can find that, then we can verify and connect C and F. We can make, because now we already know F makes all lineage under it, but can we also connect C and F, right? We can, because C and F is going to be one lineage. It's going to be one family. Let's look at that. So you can see right here, where is it found? Look at the U5 with the female lineage of the CF lineage. We can note that is in Spain, almost about 6,000 years ago. So that's exactly the biblical narrative. We want to find that lineage. So it's right here. So most likely after the split, after people was over here, some went over here, some went over here, some went over here. People split out really quickly. And the reason why is because I talked about it before, that they fought, basically. Ham, Shem, and Japheth, basically their sons fought, and they got into it, and they all diversified and everything, went to different areas. We know because there's an Isham that was in a cave over here, and D&E was over there, and they were fighting, and they ended up dividing and going different areas. I'll go get to it right now, but right here, this is going to be your CF. Who is CF? Is it going to be Ham, Shem, or Japheth? Because now we understand this is one family that's underneath here. We'll break it down once we get to it. So CF is a found fossil. That's going to be very important. So it has CFP143, and it has an mtDNA of U5. That's very important. A lot of Phoenicians, Carthaginians have U5. A lot of different people have U5. U5 is modern. So you can see right here, that's definitely going to be one we found. Also, this is how we know that CF is going to be the split. Here's going to be a quote from a genetic site. It's going to be from here. Just talk about some lineage that they found in Saudi Arabia. Remember, I told you how the earliest lineages, as we know, Ham, Shem, and Japheth, was actually in Arabia. Watch what it says here. The presence of two underived E-M60 96, which is basically your earliest E lineage, and Saudi lineages, pretty much, is basically saying that it just comes from DE Yap groups, which we know. But watch what it says here. The recent resolutions of basically that you see this CDEF, that's just basically CT. Because we know, because if you change it to CT, you already got the M168. CT is basically CT M168, which you can see right here. I don't know what just happened there. I'll just close this afterwards. But you can see right here, CT M168. So just to show that real fast, I'm gonna close that. I'll open that again when we need it. Get back over here. So let's just talk about CT, because remember I told you how CT splits and makes DE and CF. This is going to be the families under CT. So it has obviously a split of DE Yap, which only DE has the Yap lineages, and CFP143. So just let you know a little bit of some things. I'm just going to jump down to about here. Regions near, but I'm just going to jump down a little bit more. About here-ish. Just talk about some lineages in basically Arabia. Just talks about basically DE, Yap, and CF and whatnot, and their mtDNAs, right? U5 is underneath N, pretty much. U5 is underneath N. And just letting you know that basically these, watch what it says here, these would have spread globally and diversified over time and space. But remember, we already know that they first start off as one taxation or one node. So we know that these nodes will be basically your earlier lineages. So remember, A and B, D and E, and C and F. Those are going to be connected. But notice what it's going to say here about these lineages. These would have spread globally and diversified over time and space. Remember what the Bible said? It said from Ham, Shem, and Japheth, the whole world was filled. That's what we see today. Every single person today is from these lines. This model would imply that both CFP143 and DE Yap evolved nearby but outside Africa. That fits the biblical narrative because they were at the mountain, right? Where did the people get off at after the flood? Right, it's very important just to get a round idea of that area, right? We may not know the exact pinpoint where they were, but we know that at least to the time of Cain, right? Because remember, Noah cursed Cain. So when was Cain born? Was Cain born off the ark or on the ark or before the ark? That's a question of his own. But notice here about this area over here, I'm just going to make a round circle because I know it's about this area. I believe it's about Armenia, Mount Judy, about this area. So I'll just make a round circle. So they were settled in these areas and they got off. Noah cursed Cain. Things got hectic at some point. Remember, he blessed Shem and Japheth, and it ended up saying that basically the descendants of Ham would serve Shem and Japheth. Shem and Japheth. And then they end up getting into it a little later. I went into it. They remember the Tower of Babel. They end up going here. God confused their language. And how did he separate them? Did he separate them by race? No. That's very important. God separated the people by linguistics. That means language. So God separated the people by language, not by race. That's important because sometimes you'll see in certain groups with the same linguistics, you'll see that they will have certain haplogroups, but we're going to talk about which ones are the dominant ones in certain areas. We're going to get into those. But this is where they split and diversify. They go from here and they split. And that's what we know about D and E. Remember how I said that? Again, one more time. You can see even other geneticists say that right here. You can see what it says about the D and E. Where the D and E split? Apparently, the Middle Eastern haplogroups D and E split. So very important. So they split in the Middle East. Very, very important. With CF. CF obviously are in Asia. Those are going to be Asian lineage. They split in the Middle East. That's very important. But notice how it counts. The CT lineages were together. DNE and CF, but they were different and different from A and B. So now we actually can start circling some of these. So we actually have these groups are related. These groups are going to be related, and these groups are going to be related. You know what we have here? Now, obviously, we didn't find Noah, right? We didn't find the fossils of Noah, right? But we do have his sons. So if we make an unrooted chart with no root, because we don't have that root, we can actually confirm that we have 1, 2, 3 ultimate sons. That makes every single person today. How do we know they make every single person today? I don't know why. Let me open up this family tree thing, as now we need it, right? Just to show an example of that real fast. So remember, very important from the details we have seen. Remember, what I'm showing you here is called a normal chart. So sometimes in a normal chart, it looks weird, but if you look at an unrooted chart, you can see how they actually are spanning out. But you can see right here, underneath F is all these lineages. You can have J, K, I, all those ones and whatnot. Underneath DE is obviously D and E lineages. Remember, we was talking about that EM96, which was talked about. It was also in Saudi Arabia. So it's going to be early as E. Those are going to be one lineage. And also you're going to have your A and B lineages, which are also one lineage. So remember that. It's very important that we have these different lineages. Very, very important. But it makes everyone today. So A and B were one, and CT were one lineages. But CF and DE are going to be those separate lineages. So one more time, A and B are one, D and E are one, and C and F are one. So now we don't know yet who they are. We don't have a name on them. Notice how I didn't put a name on them, but we will put a name on them. Now we're going to put a name on these individuals. Let's put a name on them so that we can understand who they are. So remember, F makes all these. C and F are related. So C and F actually stem ultimately from one stem. So it actually would branch off like this. It will branch here and will branch here, and then have all these of one branch. And then this one would stem off and will branch here for B, and will branch here for A. And then these ones will also branch, and you have D and E. So remember how I said that? These branch from this middle part, 1, 2, 3, 4, because that's how an unrooted chart works. It doesn't have a actual root, but they all in the center of the root of the split, where they all stem from. That's where they will come from, right? From the center piece. On a star graph, you always count the middle as the start. Always count the middle as the start. That's very important. And then the branches will be its own lineages. So that's how a star graph works. Let's go and now break a little bit of these things down so that we can get an understanding. Now, if you already seen where we broke some of these down, we already know what they are, but let's verify it. Let's verify what they are today. And we're going to verify it by actually going over it. So very, very important stuff. Basically putting the understanding to what we just broke down. His going to be pretty much just like this, which is a normal chart from the family tree. This is also a normal chart, but this has the understanding of it. So you see how that CT is there? So again, Noah split to Ham, right? From that BT split to the A and B groups, to Shem, to the DE groups, so the DE groups, to Japheth, which is CF groups, so the CF groups. So very important. You can see all the lines under CF, all the lines under DE, and all the lines of A and B. And let's confirm it. So how do we know that's Ham, Shem, and Japheth, right? One, because we can actually logically think about it, right? Most people understand that this has to be him because it's in Africa, it's in certain places that the Cushites went and certain things like that. But then you got a choice between CF and DE. Which one is Ham, or which one is Japheth, and which one is Shem? Well, we know that the C and to these lineages show closer lines to Japheth. We're going to talk about that. And these ones have more closer ties to lineages like Javane, and where they go from Arabia to Africa and things like that. But let's break it down piece by piece now. Let's go about it and break it down so that we can go about these things. So now we just went over that. Remember, we established that the flood is real. I'm going to put that aside. We established the splits to understand how these things are split and how A and B groups don't make CT groups. That's what all these say. pretty much. It says basically, long story short, is that none of the non-African groups, CT among them, non-African CT, because remember we found it in Arabia, descended from the basically A1, all those other groups, all those A pretty much. They don't come from the A groups, long story short. Now let's go over here. Let's actually break down first. Let's break down the F groups. Yeah, let's break down the F groups. So let's break down the F groups. So if you've seen this chart, I'm gonna use this little design and kind of show some of the routes. Now you'll probably see some of these dates, like I said, exaggerated. Obviously, after the younger Dryas, right? It's gonna be very important. The years are exaggerated. That's important to go over. But let's first establish who is who. So we got a tree, and we're gonna establish first Japheth. We're gonna establish who is Japheth. I'm gonna close this and this. And if any questions, let me know as we go over these things. I'm gonna close this. And I'll leave that there. Or I'll put that right there. All right. Make sure the ones I want to go over here. All right, so let's look at this little design first. So someone else had talked about this, but one of the most important things to understand, right? There's Paleolithic time frame, there's Mesolithic time frame, and certain things like that. So it's important to understand those things. Obviously, the time is exaggerated. It's important, very important to know when we talk about those things. Let me actually open up one more note. So I actually need one more note here, which is going to be for understanding who these lines are. Just gonna grab one from here, which pretty much talks about the movement through certain areas like Egypt and things like that. Let's see what's going on there. All right, there we go. Okay, so let me just have that load up real fast. So let me just talk about this. So if you already know, right, A and B haplogroups are very important, right? Remember how I said they were linked? A monophylactic group is linked by basically one split. Here's an understanding: the unrooted haplotype polygeny reveals that almost all of the haplotypes in haplogroups A and B are linked to other haplotypes by just one single step mutation. That's very important. So very, very important to give us a little understanding on those things. So it's going to let you know that they're basically related. But A and B groups are going to be basically separated by the CT groups, right? Very important. But let's talk about something real fast. Let me go a little bit down here. So right here is just a little understanding. So we're gonna matter of fact, we'll work around. So we'll work on a lot of haplogroups at the same time. So here is gonna be A's. So you can see A is gonna, on this chart, you'll see A's obviously in Africa, right? But notice that some are also outside of Africa, right? That's very important. So over here, and around these areas. So it's gonna be very important. So we're gonna get a good understanding of that. Let me actually open up one more. One more thing, a map, so that we can get a good understanding. If you're not familiar with the Ham, Shem, Japheth locations and stuff like that, that's okay. I'm just gonna grab a map here for that. So this, I'm gonna grab one from my notes. I'll just grab it from my note because that doesn't have the whole piece, right? It's pretty much taking like stuff like multiple different documents, like what Josephus says and other different things, because Josephus talks about obviously Ham, Shem, and Japheth, where they went and everything. But let me grab something here and basically use for understanding movements and whatnot. So I'm going to basically open up this note for a picture. I'm going to grab a picture of the maps, and we're going to basically confirm who's Ham, Shem, and Japheth. But you see how we already confirmed the splits. So it's very important. We already confirmed the splits scientifically and also backed it up by the biblical narrative and the scientific method that there was a bottleneck of mankind wiping out many different other lineages. There's no Neanderthals, Denisovans today. And also we know that there was a flood that happened and catastrophic events. That's what's important, is the fact that if you're going to have a flood, you got to remember floods also cause other catastrophic events to happen, right? Very important. If the earth opened up, you can expect volcanoes to go off. You can expect all types of things to happen when you have those things happen. So that's very important. When you read that it says a global flood, obviously don't just think it's just only a flood. It's definitely going to be other events happening alongside that flood. So very important. But let me open this up. So this is gonna be something for noting where they're at. All right, so right here, we go back over. All right, so you can see right here, we have a map of the sons of Ham, the sons of Japheth, and the sons of Shem. So blue is the sons of Shem, yellow is the sons of Ham, red is the sons of Japheth. So we can see Japheth will be at the top, Shem will be right here in the middle. Now it has like this green, which are Eber. Eber is important because Eber would be where it would lead to the Hebrews, the Israelites, stuff like that. But you can see right here, Eber would be obviously in the area. This area actually would be controlled by some of the Akkadians. So it says Eber was up here. We notice because if you follow the Natufian movements, they actually curve just like that. Pre-Pottery B, they do that same thing. And also the Shemites also go across Anatolia. They're later pushed out by the Hittites because the Hittites end up filling up this area, and that's why you'll start to see E groups start to basically splash into these areas. We'll also talk about that with the D and E groups that splash into these areas. How do we know? Because we can look at the fossils and their movement, where they go. Right? Here's an example. Just gonna show one from over here. Let's open up a graph here. So here's a graph of basically the fossils of D and E and whatnot. Let me zoom in. So you can see here. So they will obviously split from about this area. Let me just zoom in a little bit. So about here, so you can see this DE. So there's older DEs that's on like single papers, but this is an example of a DE over here, and it obviously split, and you're going to have different lineages that's going to settle in these different areas and whatnot. So very important. E1B1B settles in all these different areas because E1B1B has connections to we already went over it. Jotanites, Ishmaelites, Arabians, different lineages, right? They settle all over the Levant. They also, as you can see here, remember how we talked about the E lineage being over here? But what ends up happening is as the Hittites settle here and settle in these areas, they're pushed out and they end up going outwards over these areas. And you can see here's a E-M96. So remember, E-M96 is your earliest branch of all E groups. So remember how we confirmed that some of the E groups are over here end up getting pushed out of this area. And they're going to later end up dwelling over there in different areas all over these areas. So that's also something that's important to know when they're pushing them out. But they don't dwell over there largely. Some are there, but not larger than Japheth. They're not there larger than Japheth. But they do have a large portion of some of their lineages. You can see the D over here. We're going to talk about who they are. We're going to actually put them on a chart. So let's put them on a chart. All right. So now we're going to actually put who they are. So we're going to put different sons. I'm going to put 3 lines. And we're going to put the sons. All right. All right. So first things first, you can see over here, obviously you got your basically your E's going over here. You also have up here some E1B1As up here. So you can see right here some E1B1As that went over this area that I talked about. These are going to be some early lineages. What's important is that you understand that not every what it looks like. All these dates, remember, they're exaggerated. So remember that it spans a 12,000 span, right? Remember that it spans a 12,000 span. But that's an exaggerated time frame. But anything that's underneath that is just leading further away, leading up to our time. Just long story short, to make that simple. But all these lineages existed at the same time. So remember, after the Younger Dryas, whatnot. So you can see right here, what are we seeing here? We're seeing the Mesolithic time frame. You can see different lineages over here. You got some E's there. So remember, we talked about that being pushed out by the Hittites that end up settling over here. These are going to be some of the Indo-European nations that settle here. And then they pushed out the E that's over there that was settling in the area of basically the E that actually settles there. Let me actually point out which family that is, because we're going to start graphing them and whatnot. But let me grab that picture right here. The E that actually settles there is Lud. Lud actually settles there, but it's pushed out. Lud is actually pushed out. I'm gonna actually quickly put down those E groups just to get the E out of the way. So we're gonna have certain lines. I'll show you the 5 sons of Shem. So this is actually Shem right here. I'm not gonna draw a line, but his Shem. You actually would have a D. I'll actually type it out. You actually have on this side, I'll make it a little bigger. On this side, you will have a E1, E2, E1, E1A, E2, and a E1B. Is that these will actually be some of the children of Shem. Be the 5 sons of Shem. It's actually very important. You can see when we go back over here, right? The sons, we can put some names on them if we want to. I believe that the D right here on this side right here is actually going to be, this one's going to actually be Lud. And this one right here is actually going to be Elam. I talked about it before when I talked about how Elam basically, when the Elam was destroyed, it ended up diversing into different areas. When I did a video on the Kassites, if you want to see that, it's on a video of the Kassites. I put a timestamp on it where we went over the Kassites and we talked about how Elam was destroyed and if they basically scattered into basically Japan and across India and far away. That's why D is so far away, because after the area was destroyed, they ended up diversifying far away. You can see right here. Also, we'll have certain different lineages. This one, let me go over here. I believe more so looking at when I'm going over these things, that obviously you're going to have Elam, Asher, Arphaxad, whatnot. We already got Elam, Lud, Aram. I think Arphaxad right here actually would be this lineage. Make sure I spell his name right. Yeah, AD. Arphaxad will be more of this lineage. I believe that this line will be Asher. I'll show you why. And this one, Aram. So Aram is in between these two. So this one and this one. So this is more so of what they are, more of what they would be. The reason why I'll put a video in the description of E1A and E2. I went over E1A and E2. They go into places that basically, as some of the nations fall, like Asher and stuff like that, Asher was actually taken over. It's important to know about this. Kingdoms like Babylon, Assyria, they don't just go to one phase. You're going to have different phases like Proto-Assyrians, Neo-Assyrians, meaning new Assyrians, right? Neo-Assyrians is more of an Indo-European that takes over the Levant. Later on, a lot of neo-empires is after basically some of the Arabian conquest that happens during the Bronze Age collapse. And then a lot of nations end up falling, collapsing, and being taken over by basically Indo-European invasions that happen throughout the whole Levant. It's pretty intense, but it's important to know that the Proto-Assyrians are different than the Neo-Assyrians, and the later lines are there. So they settle in Asher, but that doesn't mean that all the people in Asher are actually related to these lines. That's very important. So we already talked about that, how we found E2, E1s going into Pakistan and India, things like that. We want to take too long. Now we're going to jump to Japheth. Let's get over here and start talking about some of Japheth's line. So that's why we're looking at this. You can see some of those lines diversifying, right? Some going into these different areas over here, the different lineages, right? They're always going to be in connection to basically some of the lines that were over here, but they're spreading everywhere after the collapse. So very important from different collapses that happen over time. But let's keep on keeping on. Let's go over here. All right, so now let's talk about a little bit of, before we get to Japheth, let's talk about him. What's some lines that we know would be him? We know what we know is that him would definitely be related to those A and B lineages, and we actually have 4 from them. But let me actually show you something here. Let me go up to this. All right, and go down to this one. Let me just get where the list is of those haplogroups so I can show that. Let's go to a list here. So about here, I'll just go to one. This. All right. I'm going to go to one of these. So this just talks about some things, whatnot. Let me actually go back, because we'll come back to this. I'll leave this here. But let me point out, let's just get some out of the way real fast on Japheth's line. All right, so you can see the C's all the way over here. Now, if you already did a couple of studies on some of the trees of Japheth, there's already some interesting branches like this one and this one. Some that we already know, right? Of some of the R lines. I'm gonna pull up that star graph. We'll go back over here. So always remember on rooted chart, right here. So we know that this is what we kind of know, or basically, I'll put some videos in the description how we went over R and J and certain lines. I'm just gonna put what is the 7 sons. So here's gonna be the 7 sons, but I'll actually put him at the top first. But before I do that, let's read a couple things before I do that, because I don't want to jump too fast. We'll do a video breaking these down separate, so I don't make it too long. We already getting some time in, but we already talked about that, right? We talked about which ones are connected. The Mongoloid C, right? That's going to be connected. They obviously in areas of Europe, not just in the area of the Mongols, but also in Europe, which that was what this was showing. C is all over there. C is here. C is over there. C is also in the area of the Hittites. So you can see that also up there. So C is actually an Indo-European lineage. It's going to be very important. It could be all in these areas. And they also go into areas of the Mongol area over there. So that's very important. So remember, we already talked about how C and F came from over there, and it was with the U5. So you can see the mtDNA. So U5, 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 U5 with the I groups up there. U5 over here. U5 is going to be in a lot of these lineages. Right here, you can see these ones in the Hittite area. These have their own female lineages, but this is going to be the Hittite area. And then you can see in this little area down here, we're going to note that G. This G here, let me actually point this out real fast. Let's go down and point something out. All right, so G is actually Mahdi. G, the G haplogroup, as you see right here, you see how G, ancient G actually stretched around these areas. Mahdi, the Medes, the ancient Medes, the Mahdi of Japheth, right? Right here, Mahdi of Japheth, that become the Medes and things like that. They actually are going to be G. They settle on this area. They take over these areas and they expand. They actually do expand a bit, which I'll actually grab it from this one right here. I think this one will just show how they expand, unless I open up the same one I did. I meant to open up this one right here. All right, so you can see right here, you see that this is actually going to be G here. So there's going to be haplogroup G diversity, where it diversifies. So it's all throughout this area, throughout Iran, spills over a little bit down, a little bit up. So it really settles in these areas. So you can see right here. So G, let me see if I can maybe open this or something. Okay. All right, so you can see just showing you the center area in Iran. So where it was mainly located, Iran obviously goes in the areas with the Hittites, settle in the areas of the Hittites. They merge with some of those. They obviously going to diversify throughout Europe and diversify throughout these areas. So this is actually going to be the line of the Medes that actually spread pretty early and diversified throughout areas of, Europe and stuff like that. So let me actually put those families. I'm going to show you what are the families of Japheth. You'll have C. Let me actually move it up here. Try that again. So Japheth family is C. You're going to also have some of the F groups. So F dash M9 pretty much. You'll just put F. And we also would have under with these lineages, what's important too is that you're going to have major nodes. Those major nodes would be G, H, E, H, I, J, K, which actually makes the G. It's going to make G. And then you're also going to have H, I, J, K, which actually makes your H. And then you're going to have a split at IJK. So IJK has a couple different branches, and that's what we're going to talk about real fast, that they have a bunch of different branches underneath them. One of them we're going to just have as IJ. That's one group. You also got your K groups, but K splits into two different families. There's going to be your, let me just put it down. There's going to be your L and T groups, which is one family. And then there's going to be a group called, basically underneath K is basically P, but we'll just put K for understanding there. And K. Just make that a little longer. So you can see 1, 2, 3, 4, 5, 6, 7. You see those 7 groups? So those are going to be 7 different there's going to be 7 families under the CF lines. So 7 families under CF. So CF, G, H, I, J, L, T, and K groups. It's very important. K is going to include pretty much, as you can see here. I'll just show you basically what it is. Right? Under CF, remember CF is one node. C and F groups, right? Because C is going to make its own families. It makes C1, C2, C3s. And then you're going to get your F groups, which are going to make their own families. F makes its own families. And then underneath that, you're also going to get your GH, GHIJK, which makes your Gs. Your HIJK, which makes your H. Remember, they're all connected by one node. Your IJK actually makes your IJ, which is going to be one family. And you're going to also have your Ks. That's going to make your K, this K group, which is actually going to make all these Ks. which is all the way down here to P and all these and whatnot. And they're going to end up making basically all those lines. But there's another line under K. So under K-M9, which is actually going to be your LT. So LT underneath that K. So IJK actually makes basically a couple different sons, whatnot. But they're all basically connected by one node, to understand that. So they're going to all still be from Japheth. But those are going to be your earliest branches, right? We only found one GHIJK. We only found one HIJK. We only found one IJK. These are early nodes, earliest nodes. They're almost non-existent, but we did find them. So they're going to be your earliest sons of Japheth, the earliest sons of Japheth. Very, very early ones. Very important to get a little understanding of that. Let's go back over here. I think I accidentally opened up this thing. Close that. All right, so let's talk about what's there. So remember, K is everything underneath it, right? All those different ones. I would actually put the K that's there, right? K dash is K2 pretty much. I'll just put K2. It's actually K2. That's what another thing they call it. K2. Long story short. So this is actually K1. LT is actually K1. The other one is K2. You can see it if you was to put it down on a, if you was to type it down, like here's an example. Any questions, statements, or answers, let me know as we go about these things. So you can see right here, LT is actually also known as K1, right? It was previously K2, but it was changed after its brother Clay was found from that Isham. Right here, you can go back to KM9. This is actually K-M9. From KM9 comes two sons, K2 and K1. That's very important. It's just letting you know that they're related by one node. That's just important. Now, I just want to show you something so that it's understood. If we was to have a branch of Japheth, this is how it can easily look. It can easily look like this. F-M89, right? And from there, you can easily get, right, from here, 1, 2, 3, 4, 5, 6, 7 splits from there. And what can happen, these splits can still have F-M89, right? These lineages can still have F-M89. What I'm saying is, let's say Japheth has sons, right? And they can still have that lineage. And what happens is they start to change. They'll start to change. Here's what I mean, right? Let's say this is still F, and then let's say later on, it's still another F, and this one stays into F, and then let's say this one turns into like F1 and whatnot, and then it has this other branch. So this one makes F1, F2, F3, and whatnot. But let's say from here, from the F, right, it's gonna be F-M89. All of a sudden, it mutates. It goes through a mutation. It goes through a mutation. And it gets GHIJK from a mutation. Maybe I gotta make this a little smaller. So it has a mutation. GHIJK, right? That's very important. So from that mutation comes GHIJK, and all of a sudden it becomes a G. And let's say this one still being F, right? It then makes a GHIJK, and let's say it still continues as GHIJK, right? Let's say it still continues as a GHIJK. Sorry if it starts to look kind of confusing, making these letters, but anyone who goes over these things, you probably know what I'm saying when I go over it. Right here, so GHIJK, and then all of a sudden from that GHIJK, it will change to a HIJK. Then all of a sudden, later on from his sons, you get H. That's very important. From this one, right? Same function, right? From this one, you can get GHIJK, right? And let's say it goes on at HIJK, but all of a sudden it continues and it goes IJK. The same thing with all these. Let's say these do the same thing, right? So going to draw a line. Let's say these GHIJK, right? HIJK, IJK. And then from these ones, right, still having all those and these ones, later on, you end up getting from IJK, I and J. See what's going on there, right? And then from this one, right, from this one also, just to draw that line, let me actually move that IJ. Right, I'm just going to draw a line. Right, so from this one, from IJK, you can get I and J. Later on, right, if you know about how these split, later on from this split, you'll get I and J. So from this split, you'll get sons of I, you get sons of J. If I just showed you this, you probably wouldn't understand what's going on here, but I'm showing you that piece by piece so you can see what's going on here. Now remember, GHIJK, HIJK, IJK, all of a sudden, from IJK, you get a K. You get K-M9. Same thing with this one. Same thing. You'll have a K-M9 that also comes from this one. It goes on and continues, right? And all of a sudden, from this one, you'll get a K1. And then all of a sudden, that K1 becomes what? From K1, right? LT. LT comes from that. And then what do you get from that LT? You get a split, right? What do they make? Obviously, L and E, right? Now from this K-M9, this is where you get your many different branches. So I'm going to kind of curve it. So from this K-M9, matter of fact, not to make it confused, I'm not going to curve it. I'm just going to go up, try to make it smaller. Make it really small as I can. So K-M9, that's where you're going to get your K2, right? Going to get a K2. Let me actually bring it closer. So from K9, I'm just going to put it here. Come to K2, right? Come to K2. And then from K2 is what you got. You got to see right there's your K2. And then that's when you're going to get these branches. MNOPS, right? Which comes from it right here. So MNOPS. And remember that diversifies, right? You're going to have certain lines from P, right? From P comes Q. So P comes actually your Q, which I'll put, or maybe I'll move one of those lines from that P because it almost looks like a B. But just go a little up. So right here and here. So you're obviously going to have your Q, right? You're going to have a Q, and you're going to have a R. See how that works? How you can get all humans today from just from 1, 2, 3 people, and then obviously from here you get your NNOP or whatnot. I'm not going to do it all right here, but I'll just put one more N or MNO and S. And what breaks off early from that? What breaks off early? The O, right? The O actually breaks off early from there. You can see right here. Let's go up a little bit or to it. So it's underneath this is K2. And there's your M and your S from MS. So I guess I'll put that there just for the sake. So again, you get a split. And you're going to get, right? Don't get confused when you see this while I'm doing this. M and S. And from there also, you're going to get your O. right? So again, so M and S, and P, remember, makes Q. So P makes Q. And then you can see NO right there, which makes N and O, right? So also from here, you're going to get, I just draw a line, or let's see where we could put it so it's not too confusing. Right there at the top. So right there, you also get N and O, right? So just to kind of make it understandable, you see how from F-M89, also remember what is F split from? F splits from their CF groups. So that's very important. That's something that's also important to understand, that C and F initially began together, right? So something important, something very important to understand. Initially, now I kind of made F separate than H. If you already know, F and H basically was one. F and H was basically one. Let me just show that. So that's why one of the sons of Japheth, as you can see right here, I put C, F, G, H, or 1, 2, 3, 4, 5, 6, 7. So you see right there, 7. So you can see 1, 2, 3, 4, 5, 6, 7. I don't know why I got this extra one. Why it's like that? You can see F, you get your G, you'll get your H, and I kind of made it merge like that. That was the problem when they was too close. But that's gonna make your I and J. You kind of see what I'm saying there, right? I'm gonna just remove this one real fast. All right, so just to get a little understanding, and over here, basically, I'll just put it like this. So your C, this would actually be your CF groups. And basically, your F and your H, let's go back and back and back. So F, you see right there. So F-M89 makes, you can see you can see your F1s, F2, F3s, 19, all that. And you can know so F1, F2, F3, but then your GHIJK. And if you notice, right, from your G, you can see what's going on there. This little group. But then note that H. I want to show you what it says about H. So here's H. You can see what's going on with H. Here's H. So H obviously is going to have some lineages that's going to be basically coming from there and whatnot. It's going to be basically existing and becoming his, what's the word I'm looking for? Its own lineages. There's other places you've probably seen it where it talks about G and H, how they connect and whatnot. I'm not going to get too complex into it, but that's just a little idea of it. So sorry for that. It's so squished like that, but that's basically, I just want to give you the understanding of the concept is that you can have sons. Long story short, you can have multiple sons with the same Y chromosome. You see what I'm saying? Like you can have multiple sons. Like if, let's start putting some of these down. So remember how I said G is actually Mahdi. So let's say this is Mead, or actually make that a little smaller real fast, right? Let's say this one is the Meads or Mahdi, right? Meads and Mahdi. So right here you can see as Japheth, that's the Meads, Mahdi, right? So that means that you can have multiple Meads having GHIJK. Now, can someone with GHIJK end up having a J? Yes. One of these sons mutations can easily get one of these mutations. It's not hard for that to happen. For one of these sons to have that mutation, they can be a GHIJK, and all of a sudden their mutation ends up having their brother mutation. but it all gotta be that it all gotta come from the father's line. That means that father from there gotta keep making a J. So that's important. But more or less for the understanding is that rather the Medes will always make a G. That would be more or less that as soon as they become a G, as soon as they leave the GHIJK mutation and they become a G, is always a G, right? If it becomes a C, it's always a C. If it becomes an F, it's always an F. F1, F2, F3. F1 is going to only make F1. It can't make F2. F2 only makes F2. It doesn't make F3. F3 only makes F3, right? As soon as it gets to that further mutation, this is what I mean. So you can see right here. Let's go to F. So remember, these branches may look small, but they're actually larger than they look. So let's say if I click this, you can see there's some other branches. But let's say I like, if I click it and get more deeper into it and whatnot, it'll go deeper into the branch. As you can see, now it's isolating the branch. And, sometimes you can get even deeper into the branch. But let me go back. So you can see these different F branches, whatnot, F1, F2, F3, whatnot. This one would only make this one. So you see that stem? It will only make this one if it ever gets to there. This one will only make this one if it gets to there. It's kind of like it's just basically making a bunch of different branches. That's why if you look on a tree, it's actually very humongous. It almost looks like there's no way you can have Ham, Shem, and Japheth. But if you put it as ancestral node, that's what you will get. So just a little understanding on those things. So you can get some understanding on some of these things. So rather, I didn't put the one for C. So really this is what it would look like. C would make all C's. F would make all F's. GHIJK would make G, right? GHIJK would make G. HIJK would make H. IJK would make I and J. LT would make L and T. And K2 will make almost all of these. Basically, as you can see, M, N, O, P, which P makes your Q and R groups. So you see what's going on there. But ultimately, these ones actually would stem from IJK and HIJK and GHIJK. So that's very important. Coming from F-M89. So ultimately, they can all first have a F-M89, switch to a GHIJK, switch to HIJK, IJK. And how do we know that that's true? Because there's other examples that they show where it's like that. Like for example, let me show a list right here. Here's a example of the men found in Sidon. So if they found some people in Sidon, but notice that it puts the mutation rate, right? But the only thing that we have to cut off is that those A groups, because A groups don't actually make them. But what it does come from is GHIJK. So you can see right here, GHIJK, obviously it will come from the HIJK, which comes from IJK, which you have I's and your IJK or your IJ. So remember that IJK makes IJ. Let me zoom in so you can kind of see what's going on here. Just to show what we're talking about here. As we're talking science, we're not talking just throwing stuff out there. We're talking confirmable science. You can confirm this with a geneticist. Watch what it says right here. So GHIJK. So remember I told you F makes other Fs and whatnot. But GHIJK, right? Later on you get IJK and then IJ. And then your I and J groups are going to be different. And then from your root J, you're going to get J1 and J2. So remember, root J makes J1 and J2. Very important. So J1 is one line and J2 is another line, but ultimately from J, ultimately from IJ, from IJK. And that's how you get all these different lineages that are going to be different families. So J2 and J1, ultimately from J, from IJ, from IJK, ultimately from GHIJK, from F-M89, from CF. So very important. That's the ultimate split from CT, right? Remember, J doesn't come from DE. J comes from CF, from CT. So that's very important. Go back over here. So going back to this. So that's what I mean. So CF lineages, even your F-M89, it's going to make all these lineages that you see here. So 7 sons, C, F, right? F1, F2, F3, GHIJK, which is G, HIJK, making your H, IJ, making your I and J, and LT making your basically LT lineages, and your K2, which remember how that K2 works, right? M9 makes your K2, makes MNOP. So you can have every single person today just from those lines. And we'll get to the A groups. I'll just quickly throw it on there. This is actually the truth of the A groups. Let me show you real fast. So it's important to know that A00 actually isn't going to be your root lineage. This is a root, but A00, let me close this. A00 doesn't make these. That's 100% of the tree. A00 doesn't actually make these, because sometimes you see it as genetic atom. It would be its own branch. So this is actually A00 right here. See how it's stemming out like that? I'll also confirm it to you that this is what I'm showing you. Let me just show you an example of a geneticist that already put the names on it. Let me just show you real fast. Let me just go to it. So I'm just showing this because after, looking at all these things is what, what geneticists say and what others are saying. And it's also verifiable with the biblical narrative. So let's go back over here. Let me just show you it all broken out on a tree, which should be one of these right here. Okay, so you see right here, that's your Y chromosome atom. That's your Y chromosome atom right there. That's not A00. This is A00, A-L1088. And guess what? Everyone don't come from A00. That's important. So you can see right here, see that AL, it doesn't, see how it keeps on going? It stops right there. This is 0% of the tree. As you can see, this is 100% of the tree. This one's 0% of the tree, 0%. So you can see 0.0% of the tree, because these don't make everyone underneath the real tree, which is everything under here. You can see here, this is going to be everyone, 100% of the tree, but A00 is not every single person under the tree. That means A00 doesn't actually make everyone. It's actually, we already went over it when we went over the Out of Africa idea, and how Dr. Aaron Elhock already said is an out group. Out group means it's a separate group, right? Because A and B groups are separate groups, right? Not making CT groups, even A00, which some call atom, but geneticists don't call it atom. They don't actually call it atom because it doesn't actually split that way. But there is an atom. There is an atom that would be, we don't have that genetic root. We don't have that exact person, but we do know that's a genetic atom. So that's very important. They don't have this one, but they know it's a genetic atom. They know everyone's rooted by an ultimate node. That's why we're using a star graph. So right here, you can see an A00, very important. Now I'm going to show you it on right here. So it goes like this for him. So him would be A00, A1A, A1B, and not to forget B-M60. Those are going to be the 4 sons of Ham. So 4 sons from this line, you get 4 sons from him. You can see, if we go back to all the way to ancestral node, so you can see right there, F makes all these lineages, F-M89, CF. You can see who's CF brother. Obviously, it'll tell you in different places and whatnot. Always remember, Wikipedia isn't our master in chief, right? It has some information, has some sources, but we don't only go off of Wikipedia. Don't use Wikipedia as a guide in chief. That's important. Make sure you talk to a geneticist. CF is an immediate descendant of the CT groups, right? And who's the sibling of CF? N is the sibling of DE, right? Is immediate ancestor of both CF. Well, not, you can see CF obviously makes C and F groups. So CF makes C and F groups. But its sibling is who? DE. Let's go back a little more, right? This is where things get a little tricky. This is why we had to look at the roots here, right? Because remember, A and B doesn't make CT, right? That's the out of Africa concept. That's not true. So here's BM60. So BM60. So A and BM60. So BM60 is actually the root of all B lineages. As you can see, BM60, right, what actually makes B1, B2, and B3. So BM60 actually will be the root of all the B lineages. So very important. Very, very important. So you can see what's going on there. And remember, CT and BT, those will be like ancestral nodes. They're not actually, BT and CT would not actually be a C lineage, nor would it actually be a B lineage. That's important. It's an ancestral stem. That's important. That's very important. CT, BT are different than C and B groups. So don't get confused with that BT and CT. Very, very important. They can literally call it anything. It'll be anything. But right here, you can see A00, A1A, A1B, and BM60. A00 just has evidence of basically it comes from a pretty much atom. It has evidence. It's basically one of the ancestral clades that hold evidence of its ancestor, right? It's not something that's shocking. It's possible, right? There's other things that talk about it. Not gonna get into it right now. A00 needs a whole video to break down and whatnot. But A00, A1A, A1B, and BM60. These are going to be the branches of him. So, and those we can get, this is everyone in the world. Everyone in the world, we just fit everyone in the world on this little thing right here. And we know how those mutations work. Now, let's still confirm who are these in Japheth. So that's the Medes. Remember, we showed that, the Medes and the mutation and whatnot. Let's get back to a little more of the breakdown of whom is whom. Let me actually close this. So that's what we're doing. We're putting together all these families, right, that came from Ham, Shem, and Japheth after the younger Dryas, that everyone diversified, split, went into all different areas and everything. Remember, those dates are exaggerated. But we do have evidence of a bottleneck. Men, all types of men wiped out. All types of people wiped out. All types, right? There's no Neanderthals, no Denisovans, all of them wiped out, right? I already talked about it before. I believe those are Cain's line, completely just wiped out. So back over here. So remember, that's the centerpiece. You got your splits. These two are the same. These two are the same. And then these two are the same. And then they make their own family. So they're going to make everything that stems this way. A and B only makes A and B, right? With the A0. And then obviously your C only going to make C. And your F is going to make these. And your D and E is only going to make, either D is going to make D and E is going to make E. So they're their own families. But again, let's keep on at least filling out who is who on this. So we already went over a lot of these. Remember the C. I'm just gonna throw it on there. I believe that C is basically this one. Therese. I don't know how you say his name fully. Therese, something like that. I'm gonna put this on here, right here. And the reason why is because the places that he's found in, the places where he goes, the places where he's found. Also, we know who IJ is, we know who LT is, we know who K is. We'll talk about. So it only leaves a couple different pieces to put together. But matter of fact, we'll just put this on here, might as well, and make sure we'll put. So right here, Therese. I just want to make sure I put his name right there. And then IJ, I'm just going to show you real fast that IJ, shockingly, is actually Javane. IJ is actually Javane. How do we know IJ is Javane? Because Javane became the Greeks. Javane became one of the highest lines in the areas, different areas. We talked about it before. I'll throw a video in the description to talk about it. But I'll just quickly show it, right? I'll just show. So Neolithic Greece, I already talked about it, right? What group is in Neolithic Greece, right? Crete, Minoan Empire, Minoan area. You can do research on it. Minoans are J as well. So J2B, high portions in those areas and whatnot. and other areas and talk about different ones that are connected with that. We already talked about that and everything. But what it came down to after putting the pieces together and look at a couple different things is that it looks more connected to Javan, more connections to Javan, split into different areas. Because the haplogroup I must be Javan, because I ends up settled in these areas in certain areas. So I'll just go down. Let's talk about some movements. So those are some areas, just to quickly establish some areas. So C is over here, H, I's, look at all those I's. You can see a lot of I's here. You can see a lot of I's there. You can see a lot of I's here. You see a lot of I's there. And you see a lot of J and I's. Also, remember we talked about in the area of the Greeks, that's where J is. Also, J goes up here. That's J star. That's the root of J. J star. J actually begins here. We talked about that before when I showed the full graph. That J started here, is split. I mean, it didn't split yet. Actually, it was in one piece. That J star moved up here, and then it went over here, and it developed over here for 6,000. From 6,000 BC to 5,000 BC, J was over here in this area with I. So I, and that's your root I star. So they was developing over these areas. So, and remember that U5 from that, remember that CF that we seen over here in this area? So that U5 also in connection with them. We talked about that being in the connection with the sea peoples and Sidon and whatnot. Let's go into some different ages. All right, so you see some I's and whatnot. Let's talk about where the culture is. So up here in this area, you'll have I's up there. And you'll have in this area some I's and C. And then in this area, in the printed area here, you have obviously J, right? Remember I said, what is J? There's Mahdi. Look at Mahdi. Mahdi would have stretched from this area and reached into some of the areas with that J group. And then notice that I and J. Notice that T there. We're going to talk about who is that T, right? Who's the T group that's there. That's also Indo-European line. So IJ over obviously in these areas, they're going to have connections with these areas as well. Some are stretching all around, right? You can see what's going on here. Here's the Caucasus Mountains, some of the R1B. If you already know, we'll just throw that on there. Who is the R lines under K2 right here? I'm just going to put it on there. This line actually would be Magog. The video in the description of R, we went over it. It's like a 4-hour long video where we break down R and other lineages. Those are going to be Magog. That's actually Magog. Let me actually move that over a little bit. So that's actually Magog. So we got to find who's Gomer and whatnot, a couple different things like that. Who do we find as Gomer? This one is more Gomer right here. This one's more related to Gomer. This one has more evidence of Gomer. Now, one could say what's the word I'm looking for? That one could say they don't like how that sounds, but the thing is, they move into places with them. I'm actually gonna put the name, maybe put it a little smaller, right here, right? And this is just talking about fossils, right? Because we believe anyone can be saved. Anyone can be saved, but these are the movements of the fossils, and we already confirmed that this is Japheth, so very important. And then H. So who is H? So it only leaves one on the thing. So in a way, it's a process of elimination. In a way, find out who is whom, and then putting the pieces together. Meshach. So that's gonna be Meshach right here. And if someone doesn't agree, right, show your sources, and we'll talk about what we have, right, to go over those things. I'm showing you based upon much study, going over the fossils and everything. This is what's been found, and we can verify it. We can verify these things as well. So any questions asked. Process of elimination. Also, you can see Meshach and Tubal. So most likely this here is Tubal. So and understand, I'm gonna just put something here. There's three. There's this one, and this one can these two can switch. right? I don't know which exact one is Tubal or which one's Meshach. Meshach and Tubal basically are in the same places in a way, but Meshach and Tubal, these ones, maybe this one's Meshach, maybe this one's Tubal, right? You probably heard it. Meshach and Tubal sounds familiar, right? Seeing it, Ezekiel 38, 39. But let's go back over here. How we know those are Indo-European lines. We can take a look. Let me go up here. So you can see right here, we already broke down the understandings of F when we had talked about some of the things of F. Let me show you a place where, so here's actually where F begins. Let me just actually, matter of fact, let me open this up. So here's the oldest place in Belgium, F's oldest groups in Belgium and whatnot. And I already talked about it as movement. So here's all the F groups. I'm going to just read them out. Where does F go? F dominates all of the north. F is Japheth, right? These are all Japheth. You see what I'm gonna show you a line that goes from here and covers all the north, which is F. Let me show you real fast. Right here. All right, let me just close this one. We don't need that. I just had some extra information if someone has questions on that Mahdi, that G. But this is F. Let me show you. So here's where it starts. It begins here. And then what happens with F? So F-M89, your earliest Japheth. And it got an M star. So it's your earliest M group. So Japheth might have started with M. And then where does he go? To China. So he ends up going all the way from here, and he goes all across here, all the way to China. So right there. So Japheth takes over all the north. He covers the whole area, most likely on a conquest, saying, I'm going to claim all these areas for myself. Japheth is large. After when he does that, all of them expand and conquer all these areas. And Japheth is humongous. He conquers all these areas. Japheth is a monster in the past. He literally conquers the ancient times. He literally conquers almost all of the ancient time areas. Let me show you some other places where he goes. Let me open up that again. And that's the earliest movements of F-M89 from Belgium, China. Guess where else they go? Jordan. They go down into Jordan right there. F-M89. F-M89 goes down to Jordan. Some of the females mutate. You have some T1 groups from mtDNA. So that's going to be very early on. A little bit after it's about in the Natufian time frame. So about that time, that's why sometimes you get CF groups. So mostly C that was around with the Natufian, and some of the F groups came down there too in Jordan. So that's important to know. They go to Spain. Remember we talked about that, the ones in Spain, right? They settle in the areas of Spain. So F-M89 settle in Spain. Just showing you some of those things. This is how they remember F become GHIJK, HIJK, IJK, and obviously Hungary, Germany, and all the in-between areas, right? Germany, Hungary, obviously back to China, right? Going back to China. These ones in some areas of China. So about here. So this one in the area of China, right? With an mtDNA F1. And then over here as well with an mtDNA A. So their females have some mutations, right? That's very important. So in China, going back to Spain, China, Japheth is moving about pretty much. Japheth is really taking off. He's taking over those upper areas. He's taking a lot of areas. He ends up going even to Israel. You can see Megiddo. He comes back. This powerful, large nation comes down into the Levant, into the area, probably about the Gasulian time frame. That's about the Gasulian time frame. That's Ghasslian, Gasulian culture. They enter into the Gasulian culture. So they're conquering all these areas. That's very important because remember, they make a straight line. You've probably seen it. If you've seen the Scythian people, they live across the steppe. They move across the steppe, and that's where you start getting R's and other groups, Q's and IJs over here and whatnot. They're all coming from F-M89. So that's very important. Stretching across all those areas. So it's in everywhere. It's Pakistan, Mongolia, even Canada, right? F-M89 went all the way. It went across the seas. I don't know how it did it, but it went across the seas and settled in Canada. And we know that because we have some early lineages that are going to go over the seas and settle in Canada and whatnot. So that's not too long ago, right? That's like maybe like 15. That's like 80 time frame. So that's like, I would say, so years before present, I would say about 500, 480. So about that time frame, which makes sense. You get a lot of lineages that move over. Obviously, someone got to be there, right? Peru, they go into South America. So that one's later. That one's like 8. That's like 1,000, like 980. So you can see Peru over here. F-M89 still. This is all still F-M89, the early roots of humans, right? Because some of the mutations later will be later mutations, but you can see this will be your ultimate node of those. Remember, he goes into Russia, obviously. Areas of Russia. You can see right here in this area. So that's important. F-M89 is extremely large, very, very large lineage that goes into many different areas of the north. F-M89. Let's go back a little bit. So Meshack, Tubal, early branches, but remember F-M89 would break into F1, F2, and F3. So just understand that when I say Meshack, Tubal, they're going to be F1, F2, F3, and then obviously Tubal, Meshack, H, your H groups. So going down a little bit, you can see right here who's up there, who's in areas of Europe. Remember I talked about the Ice Age. Remember we were talking about that. We talked about that earlier when we was talking about the Ice Age. The reason why is because to show that these diversified about the same time. Not on this thing. Actually, right over here. And I'm gonna go down back to where the information of the Ice Age is. Right. And remember, like we showed with that Younger Dryas, Ice Age, these dates are exaggerated, right? So it's very important to understand. But we can get a good understanding on these things. We can get a good understanding on these things. But I'm gonna go to something on this. Let me show you something. Remember how we were touching on those Hamites? Some people may say, some people may say with the quickness that these groups never left Africa. Well, let me read something to you real fast. They did leave Africa. This is what it says. So it just talks about A00 and whatnot, obviously in the Koshin in Africa, yes, in the Bushmen in Africa, yes. But it also, as we can go into depth, it says there are only rare and isolate cases of Indo-European men belonging to haplogroup A. And we talked about that. Some of the A groups also, they can look Caucasian. It's not something, it's one of those things, and they can speak Indo-European. And this just something that is normal. Nations mixed back then. A lot of them are in the Scots, right? They're identifying the Scot. You probably know, like how you said it, Yorkshire in Scotland, right? They are a large group in Yorkshire. Irish families, right, under these surnames, right, all belonging to the same A1B. So that's very important. Helm outside of Africa. This subclade is normally found in East Africa, right? Normally Ethiopia, Sudan, but has also been found in Egypt and Arabian Peninsula, Palestine, and Jordan, because that's Canaan. That's actually Canaan. Let me actually show you a genetic paper that also confirms that. Let me go to where we go over. Oh, right here. So remember how we was talking about that, how they were in Africa? You can see right here on this genetic paper, Paleolithic Y DNA heritage, basically Cretan. They came from the area of Crete, from this area, and they went over here in the lands of Canaan. They came from the areas of Crete, just like the Sea Peoples. So they came from these areas, and they moved throughout these areas, and they settled in the Levant and in the lower Levant, and obviously in areas of Mizraim and stuff like that. So which one's Mizraim, which one's this one, and which one's that one, right? Which one's this, and that? We'll talk about it real fast. So they did go into these areas. So A and B went to those areas, moving about. with different ones. But you can see right here or here. So obviously the A1B, where is it found? If it's found in these areas, guess what it is? A1B. A1B, most likely the ancient genetic Canaan. That's probably the ancient Canaan. But rather, remember Canaan, what is Canaan's ultimate father, right? So remember right here, let's put him at the ancestral node. So Canaan, remember he goes to Sidon and he makes Heth. You got Put, you got Mizraim, you got Cush. So let's put that down. So right here, who's that? Most likely Canaan. Most likely Canaan. So just to get a little understand that. Most likely Canaan. Get a little understand it. And right, if someone feels different, if they have a different source, let me know. Otherwise, that's what I've been finding. I've been finding that the A1B seems to be Canaan, right? But you know, like I said, it is found in Egypt. Maybe it's Mizraim, right? But that's what we find, that we do find it as one of the lineages that settled in these different areas. But what really points it to what's what I look for, Canaan, is, as it says, it was certainly brought to Europe by Levant people, right? Be it during the Neolithic or later, right? Phoenicians, they say Jews, but we know that's A1B. No one should argue that these are Jews. Immigration within the Roman Empire. So just let you know that A1B was moving about with some different groups. And then you get your A1A. A1A has been found in Finland, Norway, Eastern England. This subclade is normally found, obviously, in coastal Africa, obviously, in terms of areas, and Cape Verde and whatnot. And could have come to Europe during the Paleolithic, right? Indeed, a few percent of sub-Saharan mixture was found among ancient DNA from the Mesolithic in this area. I'll just show you it on the map. And a lot of the A groups are in places that a lot of people would not expect. They would not expect for them to be in the places where they are found. But A group is the Hamitic lineage that moves in different areas. So this is where A went. I'll show you where some other A's went. So all the way up there. Want to see where some other places where A went? I'll show you real fast. Just go down here, and I'll just open up a article here. I talked about this thing before, right? It's from basically this, right? Let me go up a little bit and show what it is. So ancient human genomes, genome-wide data from 3,000 years, pretty much moving throughout the Caucasus and whatnot. Let me show you what genetics is there. I just have the thing right here just to show you those A groups moving about up in the north, right? A was taken off very early on. These are what I'm going to show you is Paleolithic, Neolithic, Mesolithic time frames. So let's just quickly show that real fast. So we zoom down. So here's an A right there in Canada. That's a long time ago. So you can see almost 6,000 years ago. A over there, right? It's the same sheet I was talking about where the E1B1A went across the seas, right? That E1B1A that went across the seas and whatnot. You got some BTs here that went across the seas and whatnot. You can see right here, obviously, different lineages that went across the seas, obviously Q and other stuff. There's another A right there. You can see right here, Argentina. Let's look at this one. Here's another one. Obviously, you get areas of Africa. Another one, area of Africa. You can see here, look at that U5. Remember, we confirmed U5, the mtDNA U5 was with CF. But remember how I said people are together by linguistics, not by race. So people were mixing very early on. It's not like what happened in the 16s and 17s and 18s when people were racist. Rather, back then, people were moving about. They just had what divided them? Different languages. God divided their language. They couldn't speak to each other, and they end up going at it, and they separated. So A mixed with that U5. Remember that U5 is a Canaanite. So we know that U5 was in the land of Canaan, also in the Phoenicians. You can look it up. The Carthaginians, that was a U5 found in a male Carthaginian male, but this one's in France. So this A group is in France. So right next to basically probably the Rhine River. So you can see what's going on there. So there's some other A groups. Just to quickly show maybe one more. Let's show one more. Oh, there's one. There's an A1B, obviously Africa, right? They know that one's in Africa. But let's see, maybe we grab maybe one more here. I'll put this in the description and stuff, so you can see some of these things and whatnot. Obviously, the genetics they get really interesting, right? If you let it guide you, that's the 1A in the land of Great Britain, right? They already talked about that, but that's a long time ago, right? Because some want to say A got up there recently. No, it was in the Bell Beakers, right? This is the Bell Beakers, right? Bell Beaker, England. Did you know that if someone knows about the Bell Beakers, that's like an ancient Indo-European peoples, but the A is in that. Look at that IJ in Ukraine 7,000 years ago. So IJ was one. We already talked about that with the U4 mtDNA. IJ was one, but that's not what we're talking about. But we have all the splits pretty much of the nodes and whatnot. I guess I'll just find one more. It don't matter even if it's in Africa. Here's one in Chaz Republic, right? You probably know where that's at, Chaz Republic. And that was almost 5,000 years ago. So long time ago. Chaz Republic. All right. So yes, A was outside of Africa. So there's a lot more, but that's good enough for now. So A was outside of Africa. A was moving about. Him. Now, who would be that one, or what would be those other ones? I'll get to some things real fast. Let's go type down something. B-M60 haplogroup. I'll show you which one I believe this one is. I believe that this is Kush. I believe B-M60 is Kush. I believe it because he goes into some of the places where the Kushites go and whatnot, obviously settle in the Nubians, right? There's 4 in the Nubians, a couple different ones in certain areas, right? They're going to be settled in certain areas and whatnot. I went over some of the ancient information. They also go into Kush. For some reason, they're obviously connected with Nimrod. How do I know? Because they're also in the Sidis, the Sidis people. Right? You probably know who are the Sidis. Who are the Sidis people? Right here, there's a Sidis. If you know who they are, where they are, and whatnot. Here's a Sidis. I'll just show you where they are. They say that they have connections with the Bantu and other groups and whatnot. Obviously, they inhabited India and Pakistan. So I believe these are the ones of Kush, because they also have, as you see in the genetics, does this have it right there? See that? B-M60. So Sidis, B-M60. I believe that that's the line of Kush. I believe this is the line of Kush. That's what I believe. Because they go into Pakistan, they are obviously going to Africa with their descendants, right? They're not going to have a large portion in the upper areas, but that's the Sidis. The Sidis are a group of people that have the Bantu E1B1A in it, but the Bantu E1B1A is the Shemitic lineage. How do we know? Because the A and B groups, just to show this, go back a little bit, a little more. You can see right here. Watch what it says here. Your E, remember your E groups are different than A and B groups. They didn't even like each other back then. You can see right here what happened with your E1B1A. It says after some studies in 2005, 2007, they looked at the fossils and they found out that the oldest groups in Africa, long story short, they were replaced by a haplogroup now dominant E1B1A, right? Who's the earlier inhabitants of Africa? Traces of ancestral inhabitants, however, can be observed today in these regions. These are the presence of Y DNA haplogroups of A M91, right? And B M60, right? So E1B1A actually replaced those lineages. And you can see right here, even in E1B1A information, you can see it replaced A1A, A1B, A2, and A3, right? And B M60, right? That's gonna be very, very, very important, right? Very, very important. So these are gonna be some lines of individuals that were replaced. So also, just, when you see some of these lines, know that even the A2, A3, they actually stem off from each other and whatnot. They make each other and whatnot. Just to get a little understanding on that. But these are the ones that were placed. These ones right here, these ones were replaced when E1B1A came down there and conquered that area. That's why E1B, I believe from our fact said, E1B1B having connections to the Jotanites and Eberites and all those whatnots, right? Moving about into different areas. But BM60 is Kush. So that means that A0 or A1A is most likely Mizraim. So let me actually put that right here, because it also is in certain areas of basically Egypt and things like that. You see where it talks about some of those things, whatnot. It talks about west coast of Africa, some areas of Mali and Morocco and different things like that. If you know, Egypt also was invaded. That's very important. Long time ago by the the Hyksos came down there, took the land from them, and then there was a different line that started ruling in Egypt, and it wasn't the original Hamite lineages. It was an R lineage that started ruling down there. And G and R, Indo-European lines start ruling in Egypt. You can look it up. The kings of late Egypt, they were ruled by Indo-European lines. There's no doubt. But the A1 must have been pushed out. It had to be pushed out during those invasions and moved about. We can find it in certain areas that make sense, like Morocco, right? Around that area, Mali, right? They must have been pushed downwards and had to leave that little area. So very important. And it's not really in Europe. Some are in Europe, but early in Europe. Obviously, if they were around Cain, if they were brothers of Cain, they were around Cain, they would have been in Europe. But they would have went downwards into areas of Egypt, most likely. So this is going to be that line. This is actually going to be Mizraim. So you can see right here, we got Cush, we got Canaan. We're going to put Punt and Mizraim. So most likely this A group over here is Put, and this most likely is Mizraim. Let me make sure. Mizraim. And now take a look at what we got here. Take a look at what we got here. Can we have three? If we look at this at a scientific method, can we have three ultimate nodes and get 4 sons from Ham, 5 sons from Shem, and 7 sons from Japheth? Yes, we can get all those things. We can get the biblical narrative where the flood happens and it wiped out a bunch of people, and all of a sudden every single person in the whole earth is actually these three ancestral nodes, these 3 lineages that comes from one father, right? And they basically have different wives, right? They could have multiple wives, right? Ham could have had Shem's wife. Ham could have had Shem, Japheth, and his own daughters, right? There was no laws at that time to stop them from basically getting with their sisters. And that's something that's important to understand. Many of the Shemites were getting with their sisters, many of the Japhanites, right? It's all types of things that could have happened, right? We're not looking at the female line because that's more complex. There's not enough sources to try to say who is of Ham, who is of Shem, who is of Japheth, of the female line. There's no way. There's just no way. But we can find this with the male's line because we got biblical documents, we got historical documents, we got genetic documents, linguistic documents, and all the documents together, put together, makes it perfectly understood. This is what we're seeing. We're seeing 3 sons that basically branch, fill the whole earth, and become their own lineages. So you can see what's going on here. So very important to understand that. So that's what we're seeing here. This is the true of the truth, right? That genetics match exactly what the biblical narrative is saying. The science actually confirms that obviously these things match, and also the science confirms that there was a flood and there was a wipeout of men, or even women or peoples, all types of peoples, not just men, but animals, all types of things were wiped out. Let me actually show the last piece of this little video.
The Y chromosome bottleneck and the younger Dryas cooling event. Let
me go back to this.
Domestication of horses and camels and open water sailing. I find it difficult to believe that a global change in human culture was responsible for the Y chromosome bottleneck. The graph shows that population sizes for all regions of the world reached a maximum approximately at the Younger Dryas boundary 12,900 years ago, as indicated by the red arrow. A simultaneous global change in culture would mean that people in Europe, Southeast Asia, East Asia, the Near East, Central Asia, and all other regions of the world coordinated their culture and sexual practices in lands separated by oceans, jungles, deserts, and mountains. This level of coordination would be extremely difficult even today with modern transportation and electronic media. The decrease in effective population size for all regions in the Y chromosome graph starts gradually at the onset of the Younger Dryas 12,900 years ago. Then it dips suddenly, and it continues to decrease well beyond the 1,300-year duration of the cold event. The increase of the effective population size is just as abrupt as the end of the Younger Dryas. The Near East and Caucasus region, in orange, recovers starting about 7,000 years ago, and it is not surprising that this area is in Mesopotamia, which became the cradle of our civilization after the Younger Dryas cataclysm. Some researchers in Finland.
So that's what we were talking about, the Younger Dryas. So in summary, that's what we had talked about. Let's summarize everything that we were talking about today real fast. As always, we should summarize what we just did. So we just talked about some of these things with the Younger Dryas, and we talk about the Y DNA bottleneck, right? All these things align exactly at the same time, and they happen, right? And then we also can note that other scientists, other people talk about that there was a global flood. Remember, we talk about that, a mass extinction. Remember, we talk about that, where he talks about right here, where he talks about the same thing, the Younger Dryas, and what happened, right? What did he say right here?
400 feet of rise.
He said the water went 400
sea
feet
level. Well,
above sea level, and we also, there was also civilizations. Few people know, but there was civilizations, like you see where there's water, it almost looks kind of shallow. The sea level wasn't always this high. There was some civilizations apparently along these banks, along the sides of the rivers, because a lot of times civilizations, they build their houses or places around the bank. Why? Because it's easier to travel outland and inland. So you can take you can take a boat from here to here, or rather around here, because that would probably be hard to do that river, but they can easily get from here to here if they make their coast out here. But if they put their coast here, obviously you got to travel inland. But they said some of the buildings, some of the places are wiped out. They're gone, right? They're underwater.
Well, prior to where they're
right?
generated.
That's what he's talking about here.
Some massive event changed life on this planet 12,000 years ago. There are
so you can see some massive event changed the whole world, said 12,000 years ago. And many societies, many buildings and societies that were built around the lower sea levels, which were lower back then, are actually inside water today. They're inside water.
Driest period, sea levels rose about 400 feet. So there must have been cities at the periphery of the continents that are now underwater, and we can't see them.
So and obviously, you know what I've been showing you. These aren't just like random people and stuff. You can see. Let me actually open this up. If you already know who this is and whatnot, these are professionals that I was showing you and whatnot to show that they are all in agreement that one, that was a piece of destruction that happened, right? Bruce H. Lipston, PhD, right? Whatnot. That's what this has and whatnot. Talk about some of those things. And obviously it had a extinction event, right? And it matches exactly with the wipeout of the Y chromosome that vanished at that same time, right? The bottleneck that happened, right? And also what's interesting is if you notice, the men's line decreased, but the women's line doesn't decrease. Why? Because all the men are related. All the men are related to one man, but all the women are not. And also, you know what else will happen after that catastrophic event scientifically? After the catastrophic event scientifically is proven that stressed mothers have more girls, a lot more girls. So stressed mothers can have more girls. Doesn't it sound stressing to have a global flood just take out all the people of the world? Imagine how the women felt. Imagine how Ham, Shem, and Japheth women felt after all those things. So you see right here, here's some advice for men who want sons. Be nice to his future mother, right? Be nice to your mother. Even Yah says that, right? Don't do treacherously to her, right? Yet more research has now obviously shown that women, right, by physical and psychological stress during pregnancy are less likely to have a boy. So you see what's going on there? So you can see a lot of stress had happened after there. So it makes sense scientifically that there was more females that would also increase in having people. More women means more children born, right? Because a woman, if you have multiple women can get pregnant. But if you have multiple men, only one of those women can get pregnant, right? So not all those men can get pregnant, obviously. But if you have a few men and many women, you can have a large population bloom. So that's very important. You can have a large population bloom very quickly. And obviously Ham, Shem, and Japheth can fill the earth from that, right? One's had daughters, they get with their daughters, and their daughters, right? Their daughters to their daughters, right? So very important. We can see that all those things match. It's important to note monophyletic families. We talked about how they split, the real way that they split. I'm not going to open up all these because it looked like they got a load. But we talked about how A and B doesn't make CT. And then we talked about how from CT comes 3 roots. So remember how a star graph splits. It splits from the center out, right? If you see a star graph, just keep making a circle and go like that. That's how it splits out. That's how a star graph goes. It goes out from the centerpiece, right? That's a star graph unrooted chart. That's how it works. And the ones at the end, A and B are 1, D and E are 1, and C and F are 1, right? And from those lines, we can get everyone today. So from DE, we can get 5 sons. We can get 5 nodes from 5 sons. From A and B, we can get 4 sons. We can get 4 sons. And from C and F, we can get 7 sons. So we can get all those ones, no problem, right? We can get all those things. All of it is scientifically sound. All of it's scaled. All of it makes sense. The biblical narrative makes perfect sense. It's truth, right? So fossils give the understanding of the movements of a lot of these things, and it all makes perfect sense. So with that, family, that's all I got for you for now. If you have any questions before I go, let me know. Or if someone wants to talk, I'll put this in the description real fast. If not, I'm gonna close it in 3:30. It's 3:28 right now, so I'll take 2 more minutes to quickly summarize. All right, 2 more minutes to quickly summarize. So timeline, let's look at a timeline here. So biblical time scale. Let's look at the biblical time scale. Let me actually open up something here. So in the first video I showed that those large years makes perfect sense, right? In fact, it makes scientific sense that the people started with large ears, like how the dinosaurs were very large, right? The environment back then was much different before the flood. Everything was watered by a mist, not by rain. Everything was watered by a mist. Everything had more, it was more oxygen, air. It was much different. We noticed because different creatures were larger, bugs were larger. It's proven that bugs increase when the oxygen is higher, right? And then all of a sudden, the flood happened. And what happened? Lifespan decreased. Lifespan decreased to a smaller portion. People were dying sooner. It makes perfect sense to what we see today, right? We're in a fallen world. We're in a fallen world, right? Age dip, a massive age dip that happens very quickly, right? It happens very quickly. So let me just scroll down. Nothing else there. Let me go back over here. And timeline, obviously, you can see long time ago. You can get from a long time ago all the way to our time. Obviously, know that when you take the scientific scale, is age and thing is counting age by carbon and certain things. And remember, they think that carbon is only made by stars. So consider that. Consider that they believe carbon is only made by stars, but it's proven that 90% of the carbon is absorbed in the earth. So if the earth cracked open and the water in the earth shot out and it was a lot of carbon inside the earth that went on across the earth, you will have astronomical scales if you're trying to date things by carbon, because someone thinks the world always been this way. But even the Younger Dryas disproves that it was not always this way, right? So very, very important to understand that. So we can see these things in a sense of understanding. It's something that we can get a good understanding of without a doubt. Let's see how we're doing in time. All right. So with that, family, that's all I got for you. With that, one more time, the families of Ham, Shem, and Japheth are AB as Ham, DE as Shem, and CF as Japheth, and all can be saved in Christ. With that, be blessed, be beloved, and amen, family. Amen.